completed his PhD from Indian Institute of Technology, Kharagpur. Also, sir has completed Master of Technology, Mechanical System Design from Indian Institute of Technology, Kharagpur, and sir has completed Bachelor of Engineering Mechanical from Jayacham Rajendra College of Engineering, Mysore, India. Speaking about the professional summary, sir is a dedicated and experienced mechanical engineering professor with over 30 years of academic and research experience, specializing in mechanical system design and tribology, proven expertise in teaching, research, and supervision, curriculum development and academic leadership, strong record of scholarly publications and institutional service, including NBA and NAN coordination.
Hello, any issues?
Hello,
No,
am I
and now
audible,
it
sir?
is audible. There was a gap as such.
Okay. Okay. Sorry, sir. So, speaking about the professional experience of sir has taught core and elective courses including design of machine elements, theory of machines, mechanical vibrations, design and drawing, manufacturing technology, advanced machines of solids, composite materials and mechanics, elements of mechatronic systems, robotics and vision system. Sir has supervised over 39 undergraduate projects, 24 MTech dissertations, and 8 PhD scholars, 6 completed, 2 ongoing across design, tribology, production management, simulation-based research. Sir has published 50 plus peer-reviewed journal papers, Scopus indexed, and presented at national and international conferences. Sir has involved in developing software for the performance evaluation of Labyrinth Seals for Bail, Hyderabad, awarded with the Best Faculty Advisor by the Bangalore section of International Society of Automation for the year 2016 and 17. So as far we go through the introduction of the sir, we are really honored and privileged to have such an eminent speaker with us, and we are very eager to listen some knowledgeable insights from you, sir. So without wasting time, I would like to welcome today's our speaker, Dr. Raghunandan K. Sir. I also welcome the participants and hand over the session to today's our esteemed speaker, Dr. Raghunandan K. Sir. Over to you, sir.
Yeah, thank you for that introduction. So now, good evening, everybody. So now, today my topic of presentation is on the research methodology and the strategies that has to be involved or that has to be adopted for doing the particular research. So now nowadays, this is a very hot topic in almost all engineering colleges as such. So now because of the presentation, now the AACT or any engineering colleges, so now they have to be accredited by NBA, and apart from NBA, so now the government, they also come out with a separate ranking, that is NIRF. So now for all these things, so now they should be having sufficient number of faculty, of good faculty with that is with the PhD is necessary. So now that is why, so now it leads to this research which has to be done. And earlier, so now unlike earlier days in which, so now it was only this undergraduate or postgraduate. So now PhD has become a part and parcel of any engineering college. And this in this particular topic, so now I would be highlighting, so now what are the basic methodology for doing the research, and in what way we can get the funding, and what are the basic terminologies that are involved in this publications. And this is one more important thing which has to be considered. So now this, whether it is at the NIRF ranking or else NBA, they look into the number of publications that we generally have. That is the faculties that they are having, or by how much the college is being recognized by the presentation. So now this research plays a very important role in almost every aspect of the accreditations over here. So now to start with, so now this will be the content of my presentation. So now the definition, I don't think it is necessary to tell more about this research, because everybody will be involved in the research. And nowadays it has so happened that So now by the time you complete your post graduation, you would be coming out with one publication. So now everybody will be aware of these publications and also. So now I will be emphasizing more on the types of research, the significance of research. So then the literature review, which is the most important aspect that has to be done. So now in order to arrive at the gaps between that particular research and the methodology, and at the end, so now I will touch upon the different things. So now which is a very important aspect as such, that is the intellectual property rights, IPR. So the IPR, trademarks, copyright, royalty, and patent. So now these will be the general presentation topics that I'm having for today. So now to start with, so now this research can be defined. So now again 1 minute. So now you can interrupt me at any point of this presentation and get your doubts clarified as such. Hope I'm audible properly.
Yes,
Yes, sir.
sir.
Okay, okay. So
Yes,
now
sir.
to start
Yes, sir.
with, so now the research can be defined. So now as the search of knowledge. So now we are telling that research, that is do the searching again once more for knowledge, or as a systematic investigation to establish the facts. So now why do we generally go for this research? So now the purpose of research is to discover answers to questions through the application of scientific procedures. So now already things have been done. So now that is when we complete one particular research, at the end of it, so now a small delta improvement or a delta thing will be added into that particular finding. So now it's not that we'll be identifying something or we'll be developing something totally new. So now even though it is not unruled, but a small thing will be added into that particular literature over there, whatever has been considered. So the main aim of the research is to find out the truth which is hidden and which has not been discovered as yet. So now the classic example for this particular statement is, so now in engineering, whenever we are deriving something, so now there will be some classical assumptions. Classical assumptions will be there. So now based on the assumptions, so now we start with the derivations and we complete that particular task and we derive an expression, and based on that, so now we do the analysis. So now suppose, so now if those assumptions were not there, so now that is finding out the truth which is hidden. So now if that particular assumption is not there, so now what would happen? So now this has to be considered, or this will be a research. That is the purpose of doing the research. So now we knock away some of the assumptions which were there originally, and after removing that particular assumption, we will see how exactly the material will behave and what will be the final condition of that particular component. So now this is what we'll be doing in this particular research as such. So now the different types of research that we're having is, so now it can be very broadly classified in 4 different ways. So now when we are telling the 4 different ways, so now every way has got a counterpart along with that. So now the descriptive as well as the analytical. So now similarly the applied research as well as the fundamental research, then the quantitative research as the qualitative research, then the conceptual research as well as the empirical research. So now in the following slide, so now I will give some classical example. So now of all these, like what exactly this research are, and in case, so now if you are guiding some of your colleagues for doing this research, so now you can take up these particular aspects, whatever is being discussed. So now either it can be in the area of this descriptive research or else analytical research, or similarly the conceptual, empirical, whatever it is. So now among these 8 different types of research, so now different identifications will be given. So now any problem that can be taken over here, and you can continue for this particular research, either for guiding a colleague of yours or doing your own research in any institution as such. So now to start with, so now the descriptive as well as the analytical one. So now these two research go hand in hand. So now the descriptive research, so now there is reports on existing situations, while analytical research, it involves an in-depth evaluation of available information. So now whatever informations are available, so now we utilize that, and that is the descriptive one. So now suppose if you're going in depth and deriving expressions and doing all those things, so now that will be that analytical research. So now the major purpose of the descriptive research is description of the state of affairs as it exists at present. So now the best example will be designing wearable devices for health monitoring. So now these topics are descriptive because they aim to observe, describe, and analyze a current situation or a specific technology's design and functionality. So now something new has to be designed. So now depending upon the existing situation. existing situation, something new has to be designed over there. So now we are citing a few examples. So now we can go. So now if it is for a civil engineer, so now the impact of climate change on infrastructure materials in a particular region, or an analysis of water management problems within a particular locality. So now this will become a descriptive research. So now similarly for mechanical engineering, so now the study of the properties of a particular material. Nowadays the important material that we do have is the composite material, so or else the alloy. So now any that is the study of properties of the new material and it's used in a new product. So now or else it can be even the effects of emissions regulation on a car design. So nowadays, so now that is Nitin Gadkari. So now he has come out with a new proposal, Gadkari. So now he is telling that so now instead of using this petrol, so now we can use this particular ethanol also. So now that is again, so now it leads. So now why exactly this one was inducted? So now it is because the environmental effects are very less. So that is why it has been brought into the picture. And again, so now there is lesser amount of pollution and also the cost is also more economical. So now similarly for an environmental engineer, so now the effects of industrial pollution on water quality in a particular locality, or a comparative analysis of industrial waste and byproduct materials within a particular locality. So now this will be the descriptive type of research that can be addressed over here. Similarly for an electrical or a computer science engineering, so now a comparative analysis of the different motor topologies, so now for a particular application, or else the designing and developing of wearable devices for health monitoring. So now these comes under the descriptive research. So now similarly, the next thing that we're having on the other side is the analytical research. So now this, in this particular case, so now the researcher has to use facts or information already available and analyze these to make a critical evaluation of the material. So now analytical engineering research topics often involve so now using advanced modeling, data analysis and computational methods to solve complex real world problems in various engineering disciplines. So now to cite a few things over here. So now the most important aspect that we're having is, so now you can see that in every engineering college, a new branch has been introduced, and it is either that BTech or BE in data sciences or artificial intelligence and machine learning. So now here, this is a very hot topic. So now for doing the research, it need not be only for the computers or else for the electronics. So now the civil, mechanical, electrical, they can apply their fundamentals into this. So now there is the data science as well as this artificial intelligence. So now if you're using this particular technique, so now it is the predictive maintenance in manufacturing. So now for the mechanical engineering, so now the heart and soul of this one mechanical is the manufacturing. So now we can develop a data-driven model to predict the equipment failures in industrial settings, thereby optimizing the maintenance schedules and reducing the downtime. So now this is one topic in which we can do this particular one, and it is the analytical one. So now, and similarly, the artificial intelligence for smart grid optimization. So now using the machine learning and data analytics, so now to manage and optimize the energy distribution in the smart power grids. So now similarly, the structural health monitoring using IoT. So now that is the Internet of Things and as well as the analytical. So now similarly, the natural language processing in engineering document analysis. So now very recently, so now one of that is the natural language processing. So now irrespective of the type of the language that we speak, so now it should be decoded and it talked over there properly. So now for this, so now we can apply this natural language processing technique to automatically process and summarize large volumes of technical documents, standards and research papers. So now this can be done using this data science and artificial intelligence in engineering. Similarly, so now the advanced materials and manufacturing. So now for this particular one, so now for the aerospace design, so now we can use this computational fluid dynamics. So now there are quite a few softwares. So now which is using this computational fluid dynamics. So now this simulates to analyze and optimize the aerodynamic performance of novel aircraft designs or propulsion system. Similarly, so now the development of novel meta materials for specific application. So now the employing the computational modeling to design, simulate and experimentally verify the behavior of new materials with engineered properties such as lightweight, radar or sound absorbers. So now for this, the best example that can be given is, so now initially we had this isotropic or else anisotropic materials, but right now the latest thing that we're having is, so now in this, that is the manufacturing. So now the additive manufacturing. So now in the case of this additive manufacturing, so now the research has come to the level of this bimetal. So now the bimetal, so now again, you can also think that in shape of this particular alloy. So now the alloy is the addition of two different materials and will be having one component, but it is in a higher scale. So now in which two different metals, so now this will be combined together either of any one of this additive manufacturing process, and one product will be manufactured. So now that is, it is called as the bimetal. It will be having more than one metal, and this one metal, it can be two different alloys or anything like that. So now this multi-scale modeling and advanced composite material. So now this is also an important material, that is the advanced materials. So now that will be utilized. So now similarly, the third topic that we're having is the applied research. So now initially the first two things that we had was descriptive as well as the analytical one. So now the present one is the applied research. So now the applied research. So now when it comes to the applied research, so now this aims at finding a solution for an immediate problem facing a society or an industrial or else a business organization. So now whatever that is in our plus two, we study this physics, chemistry, as well as this biology or mathematics, whatever we do that. So now, but when we come into the professional course, so now it is the application of the basic physics and chemistry, whatever we have done over there. So now it will be the applied science or else the applied research, the engineering that we'll be doing. So now an example of an applied engineering research topic is designing and testing a novel system for improving the efficiency of electric vehicle battery charging using artificial intelligence and machine learning, or investigating the feasibility of using the advanced composite materials for building earthquake resistant structures. So now when it comes to this particular transportation or else the automobile, so now the latest thing that we do have is this electrical vehicles, that is the electrical cars. So now wherein which the battery plays a very important role. So now higher the battery, so now the mileage or else you can travel for more number of kilometers. So now if the battery weightage or if the battery charge is more, so now that is why, so now we should come out with the new concepts or new materials for this battery charging using this particular artificial intelligence and machine learning over here. So now this will be the applied research. So now or else more of it. So now it will be that interdisciplinary research that will be more important in the applied research. So now it's not only one particular specialization or one particular branch. So now it is the combination of a couple of branches over there which will be considered over here. So now similarly, this automation, robotics, and artificial intelligence. So now the development and implementation of an automated monitoring and control system for irrigation using the Internet of Things. So now these are the few examples which can be given for this applied research. And again, the same thing. So now the development of an Android application with an anti-theft car tracking system. So now these are the latest things that we are having over here for this particular applied research. And similarly, so now contrary to the applied research, so now the one that we're having is, so now the fundamental research. So now the fundamental research, so now this is mainly concerned with the generalizations and with the formulation of the theory. So now an example that can be cited over here is the fundamental engineering research topic is investigating the use of novel materials like graphene in electronic components, such as exploring its properties for high performance transistors or energy storage devices. So now the other examples, they include the developing new algorithms for AI driven predictive maintenance in electrical grids, or studying the fundamental physics behind self-healing concrete to improve its crack repairing mechanisms. So now as you know, so now the present day the industry, so now or else the government of India, so now they are emphasizing more on this semiconductors. So now until now, so now we didn't have any manufacturing of the semiconductors. So now we were importing the semiconductors, and the most important that we had was from Taiwan. So now right now, so now quite a few industries have come out in India, indigenous, and novel materials like graphene. So now these are utilized in the electronic components and in specific that semiconductor. So now this artificial intelligence and machine learning. So now these can be utilized, and similarly the sustainable and green technology. So now this is the research into new materials, processes, and systems and nanotechnology and advanced materials, then robotics and autonomous systems. So now these are the new areas. So now in which this particular, that is the fundamental research can be applied over here. So now similarly, now this is the second one. So now till now we have seen two different aspects. So now the first one was descriptive research as well as analytical research. So now the second thing was, so now the fundamental research as well as the applied research. That was the second topic. And coming to the third one, so now in total there are four. So now the third one that we are having is the quantitative research as well as the qualitative research. So now the quantitative research, it is based on the measurement of a quantity. That is, you identify what is the percentage, that is some quantity is going to be measured. It focuses on measurable data and the application of mathematical and statistical models to solve the practical problems. So now, whereas on the other hand, so now the opposite to that, it is the quality. Now, how good it is. So now we measure the phenomena relating to or involving quality of a kind, quality or else the kind. So now these are the two different things which come hand in hand over here. That is the quantitative research as well as the qualitative research. So now, for example, so now in this particular quantitative research, that is the quantity. So now we can highlight here that energy efficiency. So now that is the optimizing the design of the wind turbine blades. So now the wind turbine blades. So nowadays, so now we go for this non-conventional energy resources also. So now earlier it was only this thermal, that is the coal industry. Then we had this diesel. So these were the two things that we had. But right now the non-conventional energy resources, it is the wind energy. Then the wind energy we have. So now we'll have to quantify. So now what is the efficiency of this? Or we should increase the efficiency of this. So now this can be done. So now this comes under the category of this quantitative research. Similarly, this material science. So now this is the study of the relationship between the particle size and oil extraction yield from avocado seeds using solvent extraction methods with a focus on the process optimization. So now you should get these materials very quickly or as quick as possible. So that is again, it is a part of the material science or else the composite materials that we generally do. And in continuation, for the quantitative research, so now we do have this robotics. So now in robotics, we can develop and test a multi-robot system for hazardous environment and quantifying the performance based on the task completion time, error rates, and safety compliance. So now that means the thing should be completed as quick as possible with the minimum disturbance or with minimum harm that is can be done to that particular people who are involved with that. And similarly, the quantitative research, so now it also applies to the automotive industry. So now in the automotive industry, so now the performance analysis of advanced electric vehicle propulsion system, then the comparing the power output, battery life, and charging efficiency. So now of different motor and battery configurations. So now these are the things which comes under this quantitative research. So now similarly, so now on the other hand, when we go to the qualitative, so that is the quality. So now we see how good that particular topic or of that particular thing is. So now it is the perceptions of engineering ethics. How do undergraduate engineering students perceive and reason about ethical dilemmas in autonomous system design? Example, self-driving cars or autonomous weapon system. So now we have this Tesla car. So now what is it doing? So now you need not drive it. You just sit in over there and do this particular operations and the vehicle will be moving on its own. So now it is an autonomous system design. So now you will have to identify how good that particular thing is and what are the benefits that we can get from that. So now it is the qualitative research. So now it is going to improve the quality of a person over there. Similarly, the work-life balance and well-being. So nowadays there is quite a lot of like we generally tell that. So now in a year, so now we will be asked to prepare at least some 6 to 7 papers or 4 papers or 4 publications, whatever it is. So now again, it will be that work-life balance and the well-being, or else when it gets into the industry, so now many work will be done automatically by the robots or else the cobot. So now there should be a work-life balance that has to be achieved over there. So now this is the quality research that will come into the picture over here. And similarly, user experience of infrastructure. So now this is a phenomenological study of visually impaired individuals' experiences, navigating smart city infrastructure to inform more inclusive urban design. So now that is for that visually impaired people. So now you should see that they are getting the best of the things available. And in order to do this, again, good things or good research has to be involved. So now for this, the government of India has come out with the smart city concept. In the smart city concept, so now different things are going to be incorporated into this particular city, and then it will be declared as a smart city. So now similarly, the team collaboration. So now how does the team spirit affect the success of complex interdisciplinary engineering projects in a professional setting? So now, as I told you earlier, so now that is the present day research. It is more of multi-dimensional or multitasking, and also this interdisciplinary work. So now that is, it has to be the team collaboration. Unless we have a collaboration, so now we cannot succeed in that particular objective, whatever has been framed over there, because everything cannot be done by every person or a single person. So now it will be the bits and pieces. So now everybody will be contributing to it, and then they would be getting it over there. So now the best example will be our Indian cricket team, that is the women team. So now they won this particular World Cup, and here again it was a collective effort which was being considered. So now people who have done very well in the initial stages, so now they were not included in the final because of injuries and all. But the team collaboration was very important over there. So now these are the things which can be attributed for the qualitative research. So now similarly, coming to the last topic of the types of research that we're having is, so now the conceptual as well as the empirical research. So now in case of the conceptual research, so now this is related to some abstract ideas or theory. So now you come out with some abstract, so now one idea you come out across with this, and it is generally used by philosophers and thinkers to develop new concepts or to interpret existing ones. So now the existing one will be eliminated, and you come out with a new concept, a totally new concept, a totally new idea, and you try to implement it. So now on the other hand, so now the empirical research, so now this relies on experience or observation alone, often without due regard for the system and the theory. So now it is generally your hypothesis, all those things comes under this particular empirical research over here. So now it comes only through these observations and by the experience of the individual. So now we will get into more details of this conceptual as well as the empirical research over here. So now the best example that can be cited over here is, so now suppose if I am designing a decentralized AI, that is the artificial intelligence powered waste management system for urban areas. So now if this thing is going to be considered, so now what will be the goal of this? The main aim or else the goal of this, now it is to develop the conceptual framework. So now because it is totally new and we'll have to start from the scratch, because this was not existing earlier. We are decentralizing, that is everything will be brought to one particular point and it will be continued further over there. So now to develop the conceptual framework for a smart and efficient waste collection and processing system, this will be the goal over here. So now for this, we need 4 different components. The different components that we need is, the first one is the decentralized network. So now this is a distributed system instead of a single large central facility. So now that means earlier we had only one large system. So now, but right now, so now it is a distributed system. So now everything will be come back into that particular one. The distributed one will be there. This is the decentralized network. And similarly, the artificial intelligence powered optimization. So now utilizing the machine learning for route optimization, waste volume prediction, and as well as automated sorting. So now this will be done by this AI powered optimization. This is a part, or it is a component of our goal to develop the conceptual framework for a smart and efficient waste collection and processing system. Similarly, we know the sensors. So now smart sensors, that is for implementing in bins to monitor fill levels as well as the waste composition. We should identify, so now what are the waste and what type of waste are there. So now whether it can be recycled or it has to be thrown away. So now it has to be sensed. So now for this, we need some good sensors over here. And finally, the sustainable processing. That is the last component which is necessary over here. So now this is incorporating concepts for waste to energy conversion or efficient recycling at a local level. So now either we can convert the waste into the energy conversion. So now this has to be done at the local level. So now for this, we need the sustainable processing over here. So now these are the 4 components that has to be considered. So now the important question that has to be addressed over here is, So now why this topic has been considered as a conceptual one? So now it is the forward thinking and aims to create a new system paradigm. So now earlier it was not there, but we are thinking forwardly and we are thinking that it can be now. Suppose if it is done in this way, so now this concept is going to work, and that is why it is a system paradigm which is going to be changed over there. So now this is the forward thinking, and hence it is called as a conceptual topic. So now it requires the integration of multiple engineering disciplines. There is the artificial intelligence, the robotics, the civil, electrical, everything is necessary. So now this is the interdisciplinary. That is why it is called as the conceptual research, and it addresses a significant societal challenge. So now with the novel approach. So now it is going to meet the requirement of the general public also. So now that is why it is termed as the conceptual design or the conceptual research over here. It moves beyond the scope of a typical incremental engineering project by proposing a whole new system structure. See, that is what I told you in the beginning. So now when we do our research for 3 to 4 years, and when we come out with one particular thesis, so now finally if you look back and see like what is that particular thing that you have contributed to this particular engineering, then finally you will conclude stating that, so now this is a small improvement, that is a delta improvement has been done over there in this particular area, in a small area. So now a small improvement has been done. So now by your research. So now whereas in the conceptual research, so now this is a new topic or a new system. This is a new system structure is going to be developed. So now it is something like a turnkey project which will be introduced, and these are the conceptual research that will be considered. And similarly, so now the comparative, we will go for the next, that is on the other hand, along with this conceptual research, so now we have this empirical research. So now we will get into like what exactly this empirical research will be like. So now this is a comparative analysis of the most effective ways of testing the power system. So now if you are going for this, if you want to test a power system, so now how it can be tested. So now the comparative analysis. So now this would involve setting up and conducting tests on different power system testing methods to compare their efficiency and accuracy. So now this is a hypothetical one. So now or else this one, that is the empirical relations will be derived over here and it will be proved over here. So now measuring the most accurate ways to forecast electric loads for cities. So now generally in that morning, so now the load requirement will be very high in the cities. So now the factories will be working and everybody will be working. So now the load will be very high. So now as it goes back, so now the evening or else in the night, so now in the city it will be less, but whereas in the residential area, so now the requirement will be more. So now this involves collecting historical data and using it to build and test forecasting models, measuring their accuracy against a real world load fluctuation. So now this again comes under this particular category of the empirical research. So now the impact of using recycled materials in the manufacturing of components for a specific product. So now again, so now what is being done is, so now instead of using that regular tar as well as this particular cement, and that is the concrete for road, so now they have come out with a novel approach of using this molasses. So now that is that waste of the sugarcane industry. So now which should be very much applicable to the Maharashtra. So now you people are growing more of this sugarcane. So now those wastes are being utilized for doing good things over there, and a part of it is also being considered for developing good roads over there. So now this is again, it increases the durability and the performance. So now this is a topic that involves empirical testing of the manufactured components over here. So now once we have identified, so now what exactly will be the nature of our particular research? That is whether it can be the descriptive or else descriptive. That is the first two that we had was the descriptive as well as the analytical one. So now or else, so now it can be that fundamental research or else the applied research. That was the second component that we had. And the third component that we had was the qualitative or else the quantitative one. And finally, the fourth category that we had over here. So now it was the conceptual research or else the empirical research. So now first identify what exactly will be the research that you will be employing or that you will be doing over here. So now once that has been done, So now the next thing that has to be considered is the literature review. So now this is the most important concept that has to be done. So now once the literature review has done, so now almost 30% of your work will be completed because you find out a goal over here. So now just to tell, so now there are 7-step model for comprehensive literature review. So now basically there are 3 phases: the exploration phase, the interpretation phase, and the communication phase. So now just to cite an example, so now when I did my research in Kharagpur, so now that was way back in 2000, I completed in 2000. So now the way in which it was done was, so now those days we didn't have this particular journals, not this many journals were there, and we didn't have the journals exactly on the net. So now we had to refer to these papers, also the journals. So now that is the hardbound journals has to be referred. So now physically we had to go there and look into that papers, whatever has been come out. So now the way in which this literature survey was done was, so now my guide had given me a time range. So now he had told that from 1985. So now 85 to 95 or 85 to 97. So now this 12 years. So now you identify or you refer to a set of journals. So now 4 or 5 journals were given, and referring to those journals. So now I had to identify. So now keywords were given. So now the keywords that were given was in tribology. So now I had worked on this particular journal bearing. So now the journal bearing, and again the stability, the steady state characteristics, some keywords were given. So now I had to see. So now that in one journal, I will have to see now what is the topic that has come or what is the paper that has come in that particular area which is having these keywords, and write the abstract of that particular paper. So now literally, so now it was written and I had written. So now right now we did not write anything. It is just cut and paste from that particular PDF, whatever we download from the net. So now those days I had written manually. So now it was almost a 200 pages book that was written. So now this was the doing the literature review. And my guide, he took almost 1 week to read that. Literally he read it, and then he ticked some of the papers. Some of the papers he had ticked, and he told that you take the Xerox of these papers and read it. And he told me what exactly has to be done over there. Because when it comes to the stability, I had done on the stability. So now when it comes to the stability, so now you have this world stability, the conical world stability, and different stabilities are there. So now it will be rooted down or it will be settled down to one particular area. So now the literature review, it was a very difficult task those days, but right now with the advent of this particular computers and everything, you have it in the net. So now you can go into this Google and give the topic. It will give you a list of papers. You can cut and paste and see this, what exactly the things that has been done till now, and what is the gap that actually we have it there, and in what way we can contribute to this particular research in this particular area. So now that is the literature review. So now this is generally called as CLR, Comprehensive Literature Review. So now this is being categorized in 3 different phases: exploration phase, then interpretation phase, as well as the communication phase. So now after this, so now it can be even done with this primary research topics. So now the primary research topics. So now these are the latest research which are happening in the present day world. So now that is why I am emphasizing more on the present one. So now it is that artificial intelligence for seismic risk assessment in urban infrastructure. This is one topic. And similarly, so now we have this 3D printing. So now that is the most hot topic that we're having in mechanical engineering, 3D printing. So now that means we'll be having advanced material, and especially it is for the aerospace application, because it should be light in weight, and it should be non-corrosive, and the durability has to be very high. So now other areas, they include also bioengineering for medical devices. So now that is the biomedical engineering that is also playing a very important role over here. So now the medical devices, so now many things are coming out. So now initially, so now checking for the BP or that sugar. So now it was a totally different thing. But right now you have watches in which it will tell you, it will count to how many steps you have gone, and what is your particular calorie that you have gained, and what is the calories that you have burned. So now everything is coming out over here. So now this is the primary research. So now in the biomedical that is going to be considered. So now this also can be implemented with the advanced materials as well as the robotics and automation, which are the very hot topics in this particular one. So now when we are applying this particular 7 tool here, so now for the primary research areas, So now the comprehensive literature review, so now it will be the identifying the problem statement, then the background, then the theoretical conceptual framework, and this identify the questions, So now give a couple of questions, then see the hypothesis, whether it is applicable or not. Then see the identify now who are the participants for this particular one and what are the instruments that has to be utilized, and chalk out a procedure over here and do the analysis, interpretation of the results, to the direction for the future research and implication for the field over here. So now this is the evidence-based decision through the primary research which can be applied. So now to put in short, so now this literature review, it is the most important part. So now once the literature review has been done, so now almost 30% of your work will be completed over here. So now once the literature review is being done, so now what is that we achieve at this particular point is the research gap. So now when we read the papers, that is the journal, so now we realize that there are some areas that have significant scope for more research and they have not been tapped by other researchers. So now we identified, so nobody has worked in this particular area, let me do this particular one. So now the research gap or a literature gap refers to such unexplored or underexplored area that have scope for further research. And that is why at the end of any literature of any thesis, so now you write the scope for further improvement. That is, suppose if somebody else is doing the research in this particular area, so now you can look into that particular thesis and then continue in that particular area, whatever has been suggested over there. So now why is it important to identify that unique research gap? So now sometimes it so happens that so now in the complete world, so now in the 7 continents, so now there are many people doing the research. So now you might come across, you have completed your research work and published the findings. And after that, you will find that another researcher has already published something similar to what you have done. So now this situation will occur. So that is why we should be very careful about the research gap. And that is why even though once you have identified the research gap and you start doing your work, so now it doesn't mean that you should stop with that particular literature review. So now suppose you have stopped the literature, you have completed the literature review in 2024 and you have started with the research. In 2025, somebody in the world might be doing on the same topic and he might have come out with the same or some different findings over there in the same area in which you are working. So that is why this literature review is a continuous process until you complete the research over here. Therefore, it is necessary to find out those problems in your research field, so now which have not been addressed before, and it will be investing your funds and resources in the right project, but also increasing the chances of the research findings getting published. So now this is the necessity of doing the literature review. So now the gap analysis. So now you should identify the broad area, research gaps, identifying the methods, viability of the research gap, then the selection of the research gap, and what is the expected outcome from this. So now this has to be identified before you start with the research over here. So now when it comes to the research strategy, so now what is the research strategy? So now it can be classified in 3 different ways. So now the first one that we are having is the deductive one. So now tests the hypothesis derived from existing theories. It moves from the general principle to specific observations and is often associated with quantitative research. See now, for example, so now what research that I did in 2020, so now this comes under the category of the deductive one. So now in tribology, that is in the hydrodynamic lubrication, so now the fundamental equation that we are having, so now it is the Bernoulli's equation. So now we have this particular Reynolds equation. We have the Reynolds equation. And for the Reynolds equation, so now we have standard assumptions. 7 standard assumptions are there. And one such assumption that we have over there is, so now the lubricant that is going to be used, so now it is going to be treated as a Newtonian lubricant. It is going to be treated as a Newtonian lubricant. That is, as the shear stress increases, shear strain also increases. So now it is a Newtonian one. So now what happened was in the present day. So now the basic problem with the lubricant is as the temperature increases, so now that lubricant, that is the thickness of the lubricant decreases. So now when the thickness of the lubricant decreases, there will be metal to metal contact. And if there is metal to metal contact, so now there will be some rattling noises and there will be vibration. So now if this has to be avoided, so now we should use good lubricants over there. So now in order to, when we are using the lubricant, so now we should ensure that the lubricant, that is the viscosity, doesn't reduce as we are using it. So now in order to ensure that the viscosity is not reducing, So now people, what they have done is in the present day, so now they are adding some additional materials, small additives. So now you can see in this particular advertisement. So now for this HP, that is the lubricants. So now for the lubricants, so now in the advertisements in the TVs, you can see that some extra particles will be added into the oil, and they will try to prevent that metal to metal contact. So now that is some additives are going to be added into the lubricant. So now when the additives are added, so now what will happen is, so now the lubricant doesn't behave as a Newtonian one, it will be non-Newtonian one. That is, the shear stress and the shear strain, they won't be directly proportional, so they will be inversely proportional. So now what my research was, so deductive one. So now one assumption in that theory of the Reynolds equation, so now that was deducted. That is the lubricants are not a Newtonian one, they are non-Newtonian one. So now if it is non-Newtonian one, so now I had to formulate the problem. So now analytical solution was to be done, and you should see like how exactly that bearings will be behaving. So now in this particular one. Similarly, the other one that we are having is the inductive one. So now this inductive one, so now this builds new theories from specific observations and data analysis. So now one of my resource scholar, he did this particular inductive one. So now what was done was, so now with the same journal bearing, so now we assume that the surface of the journal bearing is smooth enough. So now we are going for the surface roughness. We are thinking, or we are assuming that it is not smooth enough, and there is a possibility of some slip, or else because it is very smooth, or because of the manufacturing things, there will be some slip that is going to occur. So now if the slip is going to occur, then again the behavior of the complete system will be different. So now it has to be inducted, and a new theory has to be developed over here. So now that will be the inductive one. Similarly, the abductive one, that is the third category that we're having, that is the third strategy. So now this aims to understand the social phenomena through the interpretation of social actors. So now often used to explore surprising facts. So now this generally will be applied with this social research. In the social research, so now this will be done. So now that is the abductive one, that is whatever social phenomena, so now that will be there. So now this will be utilized over here, and what are the factors that is to be considered. So now that will be evaluated over here. So now these are the strategies that will be applied over here in the research. And similarly, continuing further, so now what are the methodologies? So now for the engineering research, so now the very first thing that we're having is the design of experiments. So now when you are doing this research, so now there are some coursework that has to be taken, in which one is this research methodology. So now in research methodology, a part of it will be this design of experiment. So now this is a method used to test how different factors affect an outcome. So now instead of doing the research in real state, so now we will be doing the research by the experiment. So now that is L4 or L6. So now you identify that is how many number of experiments has to be conducted. So now that will be the numerical experimentation that will be done over here. So now as an example, so now a mechanical engineer could use this design of experiments to find the optimal settings. So now for a manufacturing machine by systematically changing temperature, pressure and speed to see which combination produces the strongest product. So now there are four different aspects over here: temperature, pressure, speed. So now three different aspects are there. So now how exactly to vary this and see how exactly it is going to work. So now for this, we generally go for this experimental design or as a design of experiment. Similarly, the computational fluid dynamics. So now this involves using the computers to simulate and analyze the fluid flow. So now this is the non-destructive one. So now we see how exactly the material will be behaving. So now when we do this analysis, so now generally it will be done by this aerospace engineer. They use this CFD to simulate the airflow around a new airplane wing design to predict the performance and identify any issues before building a physical prototype. Similarly, the other methodologies that we have is the finite element analysis. So now these are basically the tools. So now this FEA, and of which the most important one will be that ANSYS, which everybody is aware of. So now this ANSYS or this finite element analysis, so now this is used to analyze stresses and strain in structures and components. So now generally the civil engineer, they use this FEA to model a bridge to determine the areas where stress is the highest under a load, ensuring its structural integrity. So now this is also one area, and similarly the statistical analysis. So now this is essential for analyzing data, and this includes the techniques like regression analysis and hypothesis testing. So now as an example, so now an electrical engineer can use this regression analysis to determine the relationship between the voltage and current in a new circuit design based on experimental data. So now a new circuit has been designed. So now similarly, nowadays this is of more important. That is the semiconductor design. So now new circuits will be developed. So now for the testing, we generally go for the statistical analysis. And the most important one, so now is the conceptual design. So now the fourth category which we had was the conceptual design and empirical design. Under the conceptual design, so now here this is the one that will be considered prototype development and testing. So now we develop a new type of device. So now, for example, a water filtration system and conducting small scale physical tests to measure its efficiency in removing specific contamination. So now this is the prototype development. So now which comes under the category of this particular, that is the fourth category over there. That is the prototype development and testing. That is the conceptual research. So now these are the different methodologies that can be considered over here. Yeah, and I hope I am audible and there is a good connection with this network. I need a feedback. Hello. Hello. Yeah,
Yes, sir.
audible, no?
Yes,
Okay,
audible.
fine. Just I wanted to check
Sir,
it. Okay, fine,
yes.
I'll continue. So now these are the things. And
Okay. Sir, just
yeah,
hide that. That taskbar is showing there. No? Google Meet
yeah.
taskbar is there.
Now it is
Just hide it.
highlighted, no?
Highlighted. In bottom side there is one Google Meet
Yeah,
meeting.
sharing the
Stop
screen.
sharing
Yeah,
and hide. You can
hide.
click on
Okay,
hide
fine,
button. Hide.
Yeah.
Yes. Okay, sir.
So
Thank you.
now continuing. So now you have identified that what type of research you are doing, and then you have done the literature survey. You have identified the gap. So now what exactly the gap is. So now you should get into the methodology. What type of methodology you are going to apply. So now after identifying that, so now let us see like what is the components of the research design. So now the first thing is you should give a title for the investigation, then the purpose of the study, review of the related literature, statement of the problem, and the scope of the investigation. So now these are the things. And again, so the objective is the most important one. When we are defining the objectives, so now you should identify what are the variables, what is the hypothesis, what is the selection of the sample. Suppose if you are doing this, that is the social survey, so then the social research, then you should identify the selection of samples. So now how many people you will take this particular sample? What is the sample of the people that will be considered, and what is the data that will be collected, and how the data will be analyzed. So now similarly when it comes to the design, so now it can be either the experimental design or non-experimental design. So now if it is the experimental design, so now we will have to set up a new equipment for your particular purpose. So now in our college, so now in our institute, so now we are developing a new concept. So now for the experimental design, and this is for this additive manufacturing, that is we are going to manufacture a bimetal. So now the bimetal will be this SS316L, that is the stainless steel 316L. So now this is one particular material which is being widely utilized in this biomedical application. So now basically this is an alloy with the steel. So alloy of steel. So now this will be impregnated, or it will be utilized along with another material. So now which is Inconel 718. Inconel 718. So now this is also basically an alloy. So now these two materials will be welded together, and we are going to get a new component or a new metal will be prepared. So now for preparing this, an experimental design. So now that means a new equipment has to be developed. So now the way in which the new equipment is going to be developed is, so now we are taking the two welding machines, and for the two welding machines, so obviously there will be two feeding materials. So one will be that SS316L and the other one will be Inconel 718. So now there will be one control unit. So there will be one control unit, and we would design, or using the control unit, we will define. So now whether the two materials should be one beside the other or one above the other. So now in what percentage that material has to be added. So now this is that experiments has to be conducted. So now plenty of experiments has to be conducted. So now primarily, so now this particular this experimental setup is coming to an end. That is, we are completing that particular process of building the experimental setup, and hopefully by December, we might start with this experiments of doing this particular, preparing the bimetal. So now what we are doing is only for these two materials, that is SS316L and Inconel. So now instead of that, so now the next person who comes over there and utilizes this machine, he can take another two different materials. So now he can do this analysis and he can prepare a particular component and do the analysis. That is the characteristics, that is the material characteristics can be studied over there for that particular component. So now this comes under this experimental design. So now similarly the non-experimental design, you are not doing any experiments. So now this is the non-experimental design. So now for this, in the experimental design, so now there are two types. So now that is the quasi-experimental and experimental. So now in the quasi-experimental, so now only part of it is experimental. So now the rest of the things is the that is we come out with that particular observations and we conclude with the answers over there. So now for the non-experimental design, so now we take a case study design. So then we see the content analysis and we see the ethnography and we focus on the groups and do the network analysis and the sociometry. So now this is basically for this social research. So now the social research, so now one of my research scholar, he had done this particular study. So now for ranking, so now we are having this ranks of the colleges. So now on what basis the ranks are being given to the colleges and in what way it is going to affect, and when that outsider, that is the end user is the general public, that is a student or else a parent. So now in what way he has to select a college. So now right now many engineering colleges are there. So now when the admission comes, so now it starts from the month of April, May. So now there will be many stalls will be open. So now they will start canvassing for their college and everything. So now in what are the activities or what are the performance that has to be considered. So now for the end user to select a college. So now he had done a research in this particular area. So now this basically comes under this social research. So now this is a case study and the content analysis, and he has to identify that focus group and come out with different graphs over there and do the network analysis and sociometry over here. So now for this, initially a hypothesis has to be developed. So now the purpose of developing an hypothesis is to determine whether there is enough statistical evidence in favor of a certain belief about a parameter. See now initially what was happening. So now when I was doing my research, so now we had only 6 IITs, 6 or 7 IITs were there. But right now the number of IITs have increased. So now 21 IITs are there. So now every state almost there is an IIT. So now in Maharashtra always it was IIT Mumbai was there, and there is no new thing that has been introduced. But in Karnataka IIT Dharwad, so now that is a new entry. So now like that every state has got an IIT, and apart from that, so now that NIT also has improved. So now initially it was named as REC, Regional Engineering College. So now they have renamed it as National Institute of Technology. Every state is having a NIT. So now both for Karnataka and Goa put together one NIT was there, that was in Surathkal. But right now Goa has got its own NIT. Like the number of NITs are also increased. And on top of it, so now this triple IT, that is the information, that is Indian Institute of Information and Technology, triple IT. So now 6 or 7 triple IT has been formulated over there. So now this triple IT, it is somewhere between this IITs and NITs. So now that is the people, that is the end user, he has got many options over there. So now many people, that is very few were getting into IITs and the less were getting into this NITs, but right the IITs have increased. So now more intake and NITs have increased, more intake, and the triple IT is there, more intake. So now the people who come to the government engineering colleges as well as the private engineering colleges, so that reduces. And more engineers are there. So now that means they should be having good placement opportunities. So now this will, now there should be a hypothesis testing to determine whether there is enough statistical evidence. So now when you're selecting one particular engineering college, when you're selecting a private engineering college or one particular one, there should be evidence. So now why this has to be selected, and what way it is good, and what is the output that I'm going to get. So now this is generally the purpose of having the hypothesis. So now the hypothesis is a preliminary or tentative explanation or postulate by the researcher to what the researcher considers the outcome of an investigation will be. It is an informed, educated guess. So now we will just guess like what it will happen if it is like this. So now it is most specific way in which an answer to a problem can be stated over here. So now we need to define an hypothesis, a tentative statement about a population parameter that might be true or wrong. So now that is, as I told you, many people are going for IITs. So now it need not be true. Many people, so they are not going into IITs. They feel that it is very difficult over there. So now instead of getting a degree in IIT, so now they feel that it is very well good enough. So if I am getting a degree from the nearby college, wherein which I will be having the home advantage. So now that is a tentative statement, whatever has been done. So now we should prove that whether it is correct or wrong. So now again the difference between a hypothesis and a problem. So now the hypothesis will tell. So now if I am telling that all people will not opt for IIT, so that is an hypothesis. It need not be correct or it need not be correct. So now, but when I tell that a problem, so now I can tell that, so now for this particular engineering, so now that is printing technology. If I tell that printing technology, so now the problem. So now none of the IITs do have this particular specialization in printing technology. It's not there. So now it is a problem for them, or else it is a problem for other engineering colleges to identify which the IITs are not having or which are having. So now it is defining the problem is formulated in the form of a question. It serves as the basis or origin from which an hypothesis is going to be derived over here. So now the hypothesis is going to be formulated. So now it is formulated after the problem has been stated and literature review has been done. So now when the researcher is totally aware of the theoretical and empirical background of the problem, so now the hypothesis will be formulated. So now the purpose and function of an hypothesis, it offers the explanation for the relationship between those variables that can be empirically tested. So now you need to test it and you need to give direction to an investigation over here. So now that is the main purpose and function of an hypothesis. So now the main characteristics of the hypothesis are, so now it should have an elucidating power. So that means once you tell that it is correct, wrong, or in what way it is, so now it should be able to tell comfortably over there. It should strive to furnish an acceptable explanation of the phenomena. So now it must be verifiable. So that means whatever is being told, so now it can be verified. So now suppose we are telling that 80% placement is there from this particular college. So now it should be verifiable and that should be correct over there. It should be formulated in simple, understandable terms. So now these are the important characteristics of an hypothesis. So now when we come to the different types of hypotheses, as with the research, so now here also we are having 8 different hypotheses. So now the descriptive hypothesis. So now these are variables. In this particular one, the variable may be an object, person, organization, anything like that. So now, for example, the rate of unemployment among arts graduates is higher than that of commerce graduates. The educational system is not oriented to human resource needs of a country. So now this is a descriptive hypothesis. Similarly, the relational hypothesis. So now the families with higher income spend more for recreation. So now the upper class people have fewer children than lower class people. So now these are the relational hypothesis. Similarly, the third one is the causal hypothesis. So now which is used to cause and what is the effect. While when dealing with the causal relationship between variables and researchers, they must consider the direction in which such relation flow. That is, for example, which is the cause and what is the effect. So now this will be the causal hypothesis. And similarly, the working hypothesis. While you are planning the study of a problem, hypotheses are formed. Initially, they may not be very specific. In such cases, they are referred to as working hypotheses because they are not true, not yet proved. So now which are subject to modifications as the investigation proceeds. So now that is being told in the beginning it is a working hypothesis. Then later on it is going to be completed as a fundamental or an important one. So now the important in the social research, we have this null hypothesis. So now these are statements about a statistical population. These are derived from a sample. These are quantitative in nature and they are numerically measurable. You can measure them. So now with this, we are having this statistical hypothesis. When we have this particular null hypothesis, so now you need to get into this particular statistics. So now there is a relationship between a family's income and expenditure on recreation. So now that means a null hypothesis may state there is no relationship between family's income level and expenditure on recreation. So now this is a statistical hypothesis. That is, you compare the income and then come to one particular conclusion over there. That is the statistical hypothesis. Similarly, common sense hypothesis. So now it states the existence of empirical uniformities pursued day-to-day observation. You keep saying every day and you come out with some observation. So now you tell that this is a common sense hypothesis. So now, for example, the shop assistants in small shops lack motivation. So now they are doing the same work every day for 24 hours in a day, or else for 8 hours in a day for 26 days in a month and 365 days in a year. So now they do same thing. So now they are not motivated. So now this is a common sense hypothesis that we're having, and the complex hypothesis. So now these aim at testing the existence of logically derived relationships and analytical hypothesis. So now it is concerned with the relationship of analytical variables. These hypotheses occur at the highest level of abstraction. So now the characteristics of a good hypothesis. So now it should be conceptual clarity, specificity, testability, availability of techniques, then consistency, objectivity, and simplicity. So now whenever you are going to develop a hypothesis, so now these are the good characteristics that has to be considered. So now what will be the source of this particular hypothesis? So now either it will be the theory, observation, analogies, intuition and personal experience, findings of studies, state of knowledge, culture, or continuity of research. So now again, when it is this particular one, so now here I am emphasizing more on this particular social research, because social research is one particular area wherein which it is not it is the qualitative type. So now that is a lesser number of technical things will be there. So now not much of mathematics is involved. It is just the statistics, and it will be the surveys that will be done over here. So now I'm taking an example of this particular one, wherein which you go for this sampling. So now the sampling is the process of selecting a small number of elements from a large defined target group of elements, such that the information gathered from the small group will allow judgments to be made about the larger groups. So now, for example, I told you that. So now identifying how good an engineering college is. So now you get the information from the general public, and you identify or you develop a hypothesis, and then you are going to prove that particular hypothesis. Whether that hypothesis can be true or wrong, or it can be that null hypothesis or whatever it is. So now when you're doing that, you cannot identify or you cannot do the survey with each and every person in India. So for that, you identify a sample. So now the sample that you're going to identify is, so now you are going to restrict this particular survey only to the people of one particular district or one particular taluk or one particular state. So that means you are defining your sample over here. So now once that has been done, so now the basics of the sampling theory. So now you should identify the population, the element, the defined target population in the sampling unit as well as the sampling plane. So now this has to be identified. So then always, so now we should see. Now when you are doing it for a small sample of that is in one district. So now when you are extrapolating it for the complete state or complete country, so now there will be some errors which will be creeping into the system. So now the sampling error is in any type of bias. So now that is attributed to mistakes in either drawing a sample or determining the sample size. So now you should be very careful in that. So now there will be errors. So now you should overcome these errors suitably over here. So now there are enough statistical tools for identifying these samples as well as that error. So now the latest one that we're having is that the Tableau. So now earlier it was this SPS, but right now this Tableau. So now it is giving a very good results. So now it is very user friendly and many icons are there. So now we'll be getting the results very quickly using this Tableau. So now similarly developing a sampling plan. So now you should define the population of interest, identify the sampling frame, select a sampling method, then determine the sample size and execute the sampling plan. So now defining the population of interest. So now what is that particular interest? So now it will be the geographic area, that is either of that only state or district, whatever it is, and the demography and the usage and awareness. So now the sampling frame, what should be the frame? So now the list of population elements, that is either it will be the people or companies or houses or cities. See, now this need not be done. So now the example that I cited was that engineering colleges and getting into the engineering one. So now in the marketing, they do this a lot. So now, for example, you consider this particular, this one, that is a fast moving consumer goods. Fast moving, that is FMCG, fast moving consumer goods, FMCG. So now which is the big company that we're having for FMCG? So now that is a fast moving consumer goods. So now which is being utilized over here. So now the best example is ITC. So now ITC is doing everything. So now it's not only that tobacco thing. So now they are even into. So now when that tobacco was there, so now the government of India, they came out with a particular condition that so now the tobacco products has to be written that what is the problem that you're having by using that particular product. So then it was the cautionary things were done. So now then that particular profit reduced for this ITC. Then they had to bifurcate or they had to expand. So now what they did was, so now they got into this particular educational institution. So now you can see that they have come out with its books, and the books that they are manufacturing is named as Classmate. So now you can see that every student will be having that Classmate. So now they are addressing that big population. So a big population they are addressing and they are going for this. Now it is a fast moving consumer good. And similarly, this is soaps, detergents. So now these are all fast moving consumer goods. And whenever a new product comes, so they will have to do this particular survey. Either that survey will be in only that particular city or district or state, wherever it is, and they will have to identify what is the problem with the existing product and how it can be improved. So now that is a part of research. So now which will be the conceptual one. So now the difficulty, so now the sampling frame, it has to be difficult to get an accurate list. So now the sampling frame error. So now if there are any errors, so now that should be omitted or you would be able to remove that particular one. So now for the sampling methods, so now the thing that we are having is that probability sampling and the non-probability sampling. So now the statistics plays a very important role over here. So now for the probability sampling, so now it is a simple random sampling and systematic random planning. And for the non-probability, it is the convenience sampling, judgment sampling. So now these are the basic things that you generally do in this research methodology when you start with the research. So now this is a compulsory subject which has to be done for this when you start with the research. So now similarly, simple random planning sampling, it is a method of probability sampling in which every unit has an equal non-zero chance of being selected. Similarly, systematic random sampling. So now this is the method of probability sampling. So now in which the defined target population is ordered and the sample is selected according to the position using a skip interval. So now these are the things which will be considered for that sampling. So now this is a part of that this one, that is the research methodology which you will be doing it over there. So now I will skip these things, and once you are done the sampling, so now we should come to this data collection. So now the data collection possibilities are wide and varied, with any one method of collection not inherently better than any other. So now each has got its own advantages and disadvantages. So now the data collection process, so now it can be through planning or well-considered development, effective piloting, varied modification, deliberate implementation. So like this, these are the different things. And you will be going for the survey. So now when you're going for the survey, this involves gathering information from an individual using a questionnaire. So now the surveys can reach a large number of respondents, or it can be designed survey instruments capable of generating credible data. However, it can be difficult over there. So now the survey types, so now it can be, so now similar to that research as well as that hypothesis. So now the surveys also can be descriptive or explanatory, involve entire population or samples of population, capture a moment or map trends. So now it can be administered in a number of ways. So now the survey construction. So now you should formulate the questions very properly when we are doing this. And apart from the survey, you can also go for this interviewing over here. The interviewing can be done for that individual who are using that particular product over there. The interviews can be that formal or informal, structured or unstructured, or it can be done one-on-one go over there. So now these interviews can be done by questions, or you can give a set of questions and then get it answered over there. So then finally, once the data has been collected, you see the observe. So now you see how exactly these particular results have come over there. So now the observation relies on the researcher's ability to gather data, though their senses, and allows researchers to document actual behavior rather than responses related to that particular behavior. So now the observation types, it can be non-participant, candid to the convert, and also from structured or non-structured. So now there is a specific process of observation also, and after that we go for this experimentation. So now which will be that pure experimentation. So now or else real world experimentation and the questionnaire surveys. So now these have some basic advantages, disadvantages, and also this online surveys which are more utilized nowadays. And the interviews can be face to face or door to door, or you jump into a particular mall and you get this particular interview from the people who are come to the mall over there, or you do this interview through telephonic conversation. and then again it can be the web-based questionnaires. So now a set of questions will be put in the web and will be asking them to answer them. So now that is just like creating a form. That is MS forms will be created and will be distributed. Then the computer assisted personal interviewing, that is the CAPI. So now this also is a part of it. So now once you have done all these things, so now that is what we have done is we have seen the different types of research. Then we have seen this particular examples of that, and the hypothesis we have developed, and we have done this data collection. The survey has been done, and finally it comes to this particular intellectual property right. So now this is the most important thing. So now these have been, so now intellectual property rights. So now these have been defined as ideas, inventions, and creative expressions based on which there is a public willingness to bestow the status of properties. So now nowadays, so now that NBA or this NIRF, so now they ask, there is a separate component for this, how many patents you have or how many IPRs you have developed over here in your college or from your department. So now this also plays a very important role. Once the research is completed, so now if you are able to develop a intellectual property right, IPR, then you should go for that immediately. So now, or else you should tell, that is the patent. A patent should be filed. So now patent is a recognition for an invention which satisfies the criteria of global novelty, non-obviousness, and industrial application. See, now the patent, it need not be very big things over there as we are having. So now as we think, now a particular process. So now you are completing a process of manufacturing a component through a process ABC. So now instead of doing it in ABC, if you are doing it in another way, APR, if you are doing it in that particular way, and if you are able to prove that this is going to save some time and it is going to save the total cost that is going to be incurred, so now you can go for a patent for this particular process. So now that is how many of the engineering colleges are going for this patents for this particular one. That is the patent will be developed. And again, similarly, this trademark. So now once the patent has been developed, so now they go for this trademark. So now you can see now that initially we had this syntax. So now what is the syntax? It is a water storing device. So now basically it is a water storing device, and it is a company which manufactured this water storing device. But what we tell is, so now that water storing device itself, we tell that it is a syntax. So now that syntax is just a water storing device, and now, so now this water storing device is manufactured by different companies. Like it can be Sunrise, or it can be Dollar, or it can be anything for that. So now whatever the name of that, but we don't tell that name, we tell that it is a syntax. But syntax, it is a name of the company or which started or which invented this particular water storing device. And similarly, we have the same example for the Xerox. So now Xerox is the name of the company which invented that particular instrument for taking the photocopy. So now we are not telling that I will take a photocopy of the paper. We tell that I will take a Xerox of that. So now Xerox is the name of the company which invented the photocopy. So now similarly, that is the trademark. These are called as the trademark. So now once that applicant is being done, so now we should proceed it to the Office of Origin, and it will be produced to the World Intellectual Property Organization. So then there is a 3 different stages are there. So now it will be going through that, and the trademark will be given for that. And after that, we get the copyright for that particular one. So now suppose when you are writing, so now whenever you are publishing a literature, when you are publishing an article, so now at the end of that, you should give that copyright to the publisher. So now you sign some document stating that, so now whatever has been invented or whatever has been derived over here, so now this will be the copyright of the publisher. So now you are giving that particular statement over there. So now that is the copyright. And royalty. So now when you get into this royalty, see now nowadays everywhere the conferences will be held. So now once the conference is being held, so now they will tell that the proceedings of this will come in this lecture series. It will come in one lecture. That is the Springer lecture series. So now if it is coming in that lecture series, so now whoever is publishing that, so now if anybody is purchasing that particular lecture series, so now they will be given with the royalty. So now the publisher is going to give the royalty to the editor of that particular lecture series. So now this is called as a royalty. It is as good as publishing a book. It is as good as publishing a book over there. So now it's almost 7:22. So now 8 more minutes. So now with this, so now I will come to this, that is how you are going to apply this. So now when you are applying this to the present one, so now you should jack into this, the thrust areas. So now when you are doing the research, look at the thrust areas. So now in India, the present thrust areas that we're having is that artificial intelligence and machine learning. sustainable and renewable energy, cyber security and data sciences, advanced materials and manufacturing, biomedical engineering, aerospace and drones, quantum computing, climate resilient infrastructure. So now these are the thrust areas. So now when you're applying for some funding, so now for research, so now you ensure that, so now your area comes under any one of these things over here. So now these are the thrust areas. So now when you're doing this and for getting this, so now the government has, India has come out with this imprint program, that is impacting research, innovation and technology. And AICT, now these are they being given with the good priorities. So now once it is given, when this imprint and AICT are given with these priorities, you can approach them for any suitable funding and it can be done. So now as it was told, so now these are the thrust areas, and under these thrust areas, so now these are the things that will come across. So now this is the different things that will come under this information and communication technology, in engineer, energy and environment, these are the topics. So now in healthcare and biotechnology, these are the topics. And in advanced materials and manufacturing, these are the topics. And in strategic and core sectors, so now that is the defense and aerospace. So now this will be the one, or else the infrastructure. So now this focuses on the sustainable construction technology, earthquake engineering and structural health monitoring and smart cities development. So now these are the things. And where do you get this particular funding from? So now for getting the funding, so now there are many government ministries and departments. So now the departments that we are having is DST, that is the Department of Science and Technology, Ministry of Electronics and Information Technology, Department of Biotechnology, DBT, Ministry of Defense, and similarly Ministry of Chemicals and Fertilizers. So now these are less known. So now nobody goes into some of these particular industries, and of late of these ministries, and of late the government of India, that is Modi, has come out with Anusandhan National Research Foundation, ANRF. So now one of my colleague, he has got this particular award, and he is getting this ANRF. So now there is the Anusandhan National Research Foundation. He has got that. He has got around 3 lakhs for doing the research in particular area over here. So now apart from these things, so now there are some specialized agencies also, like DRDO, ISRO, CSIR, SERB and ICMR. So now similarly, these AICTs, autonomous bodies like AICT, UGC, then INSA. So now then Indo-US Science and Technology Forum. So now these are the things. So now we are not getting into this. If you are getting into this homepage of these things, so now there are different openings which are readily available over here. So now similarly, private and industry funding is also there. So now this comes from this R&D expenditure and also from the CSR funds. So now the government of India has told that, so now you cannot keep all the profit for you itself, that is for the industries. Now suppose if Reliance is making a profit of 200 crores. So now some 2% of that has to be given for the corporate social responsibility, that is the CSR. So now CSR fund will be generated and it will be utilized for the general public. So now this is applicable for each and every industry or each and every organization, even the banks. So now they are having the CSR fund. So now whatever profit they are getting, a portion of it goes into the CSR fund, and using the CSR fund, so now they should generate or they should utilize these funds to the general public. So now using the general public, you can do this particular research also over here. And similarly, the international funding and collaboration. So now this can be done. So now there are European Union funding programs, then UK research innovations. So now these are the different things that we are having. So then of this, since we are more familiar with the AICT, so now the AICT, so now it gives that RPS, that is the research promotion scheme. So now this is one which is given and it is valid for 3 years and it gives to around 25 lakhs. And there is an AICT doctoral fellowship also. So now in the thrust areas, so now in some specified AICT approved institutions, you will be getting this AICT doctoral fellowship also. And the postdoctoral fellowship also is being given by this AICT. And that old machines, whatever we have in our lab, so now that can be removed and new machines can be placed. And for that, this more drops is one more thing which is given by this AICT. And similarly, AICT INAE teachers, the research fellowship scheme is also there. So now these are the different things that we get from the for getting the fund from the industries as well as from the organizations over here. So now after this, there are some terminologies which we'll be using, that is APC, article processing charges. Then I will be sharing this particular PPT with you. You can utilize this. and because that APC, whenever you are going for a publication, then they will be asking some charges, APC. So now you need to pay them. So now they're paying them why this has to be paid and what are the charges for that. So now it is called as the article processing charges. And similarly, what is that citation? So now again it depends. So now that NIRF ranking or else that NBA ranking, it depends upon the citing. How many citings are there from your institution? And similarly, one more thing is the DOI. So now whenever you have a publication, they will be asking for the DOI. This is a digital object identifier. What are these things? So now these are being signified or it has been told over here. And when you're giving this particular, when you're completing a publication, so now they will be asking for this ORCID ID. So now that is the Open Researcher and Contributor ID. So now one ID will be given to you and you will be known with that particular number and all your details will be in that particular ORCID ID. So now similarly that impact factor, open access, so now peer review, so now they will be reviewing your journal or your thing, and similarly the plagiarism, then the preprint, then the postprint. So now these are some of the vocabulary that will be utilized or some of the terms that will be utilized. So now when you're using this particular publications. So now with this particular one, I have tried to as much as possible information. So now basically this research methodology, this itself, so now is a short-term course for which is done for 6 days. So now one of my counterpart, one of my contemporary, when we are doing research at IIT Kharagpur, so right now he is in NIT Rourkela. So now he is organizing a 6-day course on this research methodology applied to thermal engineering. So now he is going to discuss all these things. We had a talk about what are the things that has to be told and how it has to be told. So now 6 days. So now we'll be discussing only on this. So now whatever has been, or whatever was planned or what was being done in 6 days, I've tried to do it in just 1.5 hours. I hope that it was useful and I would appreciate to have your feedback or any questions for that matter in this at the end of this particular presentation.
Sir, good evening, sir.
Yeah, good evening.
Sir, it is audible, sir?
Yeah, audible, yeah.
Yeah, having small doubt, sir, regarding hypothesis testing.
Yeah, sure.
Sir, it is possible to apply this hypothesis testing to heat transfer analysis or heat transfer
no. It is more of this particular social survey and rather than not specifically because there what you can do is you can measure the things over there properly. So now even though you tell that it's an hypothesis, so now for example this particular that is the cooling of a component, it takes more time in this particular process or lesser time. So now basically it will be an hypothesis in the beginning, but you can prove that by conducting the experiment, you can prove that whether it is null or not. So now in the way, so now you can tell that it can be proved or it can be unproved. So now a hypothesis can be generated over there also. Nothing wrong with that.
Okay.
See, that is what was being told over here. So now here, 1 minute.
Yes, sir.
Yeah, 1 minute. I'll come back to that specifically. Now, characteristics. So now it should strive to furnish an acceptable explanation of the phenomena. That is when we are telling that to the heat transfer when we are telling. So now this takes more time or lesser time, or as the cooling time will be less or more. So now that will be an hypothesis. So now it will be having. So now it must be verifiable. So now it will be having all these characteristics. So now that means it can be considered and hypothesis can be considered for this particular one also. And it should correspond with the existing knowledge also. So now it can be considered. No issues with that.
Thank you, sir.
Yeah.
Having one more doubt, sir.
Yeah.
So, is it possible to get the primary data in order to utilize any research work?
In the sense?
In the sense means for writing journals or for doing some other.
See, now this getting the primary thing, so now it can be done in 2 ways. So now one way is, So now you do a literature survey and you find out a journal or find out an article in which the experiments have been done. So now when the experiments have been done, so now there will be some 3 or 4 different variables. So now you take it for granted those particular results, whatever is there. So now by taking those variables for granted, so now you can continue the thing without conducting the experiment. So now what can be done is you can go for this Taguchi analysis. You can go for the Taguchi analysis, and in this particular analysis, you extrapolate the data, whatever you have collected from the critical literature. So then you can see like what will happen if the pressure increases and when will be the efficiency will be more if that the pressure drops or something like that. So now it can be done by the Taguchi analysis. So now that is what I told in the beginning, that is the design of experiments. So now you identify the different variables. So now you get the data from the previous literature, and using that data you do the experiments. You do the experiments in the sense you are doing the numerical experiment. Numerical experiments you are not doing real-time experiments. So that way it can be done. There are many publications which have come out with this type of analysis, that is the Taguchi analysis.
Thank you, sir. Thank you, sir.
I hope that answer was convincible.
Hello.
Hello.
Good evening, sir. This is Aisha.
Yeah.
I'm from Bangalore. So, I would like to ask regarding the same primary data set. Now, there is a study with some standard data set, and there is a model built, and everything is ready. Now, I am going to build a new primary data set, like get the data set and apply those methodologies to these newly got primary data set. So, if some paper publication should happen, like would there be any issue with that, like with this, if I'm working with the same methodology for this data set, maybe
And
somewhere
then
with a slight refinement?
a slight refinement. So now you should specify that particular refinement, and again at the same time you should specify. So now from where that particular data, that is the primary data, was taken. See now, for example, I'll tell you. So now the best example that can be cited over here is, see now there were 4 variables in one particular, or else let me take the best example of that bearings in which I have worked. So now in that particular hydrodynamic lubrication, so now the variables that we're having is that pressure, that is the important one, and the film thickness. So now these are the 2 important parameters that we're having. So now because of these 2 things, so now we get that load carrying capacity, then the friction, then the heat leak, that is the side leakage, all those things we'll get. So now into this, so now I can incorporate another thing, so now which is that a non-Newtonian lubricant. So now what I'll be doing is, so now I will be modeling the complete setup in a different way. So now I should be able to relate the present model that I have developed with the earlier one. Or what is the thing that I have done is, so now when N, there is the power law index, when N is equal to 1, so now the complete equation reduces to the Newtonian lubricant. So now if N is greater than 1, it will go to the shear thickening fluid. If N is lesser than 1, it goes to the shear thinning fluid. So now I have not done any experiment. So now I have done the numerical experimentation, but I've spent a lot of time in developing that particular model over there. So now once the model was being developed, so now I varied this particular value of N. So now when N was equal to 1, it is a Newtonian lubricant. I have got sufficient literature. So now in which experiments have been done for the Newtonian lubricant. So now I compare my answers with this to the non-Newtonian lubricant. Either N is greater than 1 or N lesser than 1. So now when I am writing the paper, I suggest or I write it in such a way that when N is equal to 1, I get this answer. So now this is matching with this particular publication. So now on this basis, I give the different values for N, either for the shear thinning or shear thickening. And this is the result that I am going to get. And these will be the parameters that I am going to conclude. So now this way I have done, and I have published quite a few literature in this particular way. Quite a few articles have been published. There is nothing harm in that, but you should specify. So now to which one you are comparing.
Okay. So basically, if I'm talking about any medical images, basically image processing and medical images.
Medical
So
images,
that's
yeah.
where I wanted to ask. But however,
So
I got your point, sir. I have some knowledge regarding mechanical also, so there's no issue.
okay.
Somewhere this is what I was asking about. Maybe yeah, I just got it. Thank
No, but okay, yeah. No, but
yeah.
that medical images now, what will happen is, so now that will vary quite a lot from person to person. It is not the same for everyone. So
Yes,
now that
yes.
is why generally we cannot compare as such. So now there what we can do is we can give that qualitative measure we can give. So now for this
Okay.
particular image, the process or we are getting this result, the quality of the result was in this way. And for this
Mm-hmm.
particular image, now that is from a different person. So now the process or the results that I am getting is in this way. So the trend of the
Mm-hmm.
result is in the same way. So hence it is feasible. We can conclude in that particular way.
Okay. So basically, what data sets available are mostly not Indian. So if I am taking somewhere the Indian data set, I'm going to get a primary data set from the, Indian locality, maybe from in and over my region, then maybe
Okay.
that would really help to me, right?
Yeah, that's what. Yeah. It is the trend. That is the quality of the results is more important when you
Okay.
go for this medical things.
Yeah, yeah.
Okay.
Okay. Okay. Thank you so much, sir.
Okay, fine. Any other questions?
Sir, my question is development of the model through
Yeah.
machine learning algorithm is which type of research?
Yeah. Developing that this one that is the artificial neural network or else this particular ANN that is the machine learning. Yeah, that's what. See now you can develop the model and you can extrapolate the results over there. See now, they might have, that is, somebody might have conducted an experiment and they would have published a this one publication. They might have, they might have published an article. So now they might have done it for one particular range. That is, the speed is up till 500 RPM. So they have not gone beyond the 500 RPM. So now what you can do is you can develop a model. So now for that particular application using this artificial neural network or artificial intelligence. So now this artificial neural network, you can develop a model and you can extrapolate that. So now beyond 500 or 600 and then you can compare the results. So till 500. So now it is the published literature we are having. And suppose if it is going beyond 500. So now where exactly the material is going to fail and what is the maximum load the a machine can withstand. So now in that way you can conclude.
Okay, thank you.
So we have got many latest papers in this particular order also. They are not because conducting an experiment, it will take quite a lot of, that is huge investment has to be done. And when you are going, so now there will be minute change in the sense. So now that parameters will improve by 1 mm or 2 mm. So now measuring to that particular level is very difficult. So now that is why they are going for this non-conventional experimental status like this, that is statistical one, or else that numerical methods, this ANN artificial neural networks. So now they develop the results and they extrapolate it and then they conclude the results over there. And for the comparison one, they give it to the standard one which has been done for the experiment.
Okay.
Hope I'm answering your question.
Any other
Yes, sir.
questions from the floor? I hope sir has cleared all the doubts, and now it's time to say a vote of thanks to our esteemed speaker, Dr. Raghunandan Thomas, sir, informative.
Then until you are ready for the next particular lecture, that is session number 10. So shall I log off? Hello. I'm going to log off.
Hello,
Yeah,
am I
audible.
audible?
Shall I log off?
Hi, yes, sir. Thank you so much for the
Okay.
informative
Thank you.
session, sir. Thank you.
Thank you for your patience listening.
Participants are requested that we start within few minutes.
So shall I start? I think Dr. Samant.
Participants are requested that as soon as our next guest will join, we'll immediately start the session. So stay connected with us. Good evening, everyone. Am I audible?
Yes, madam. Yes, audible.
So good evening, everyone. We are very sorry to convey you that today's our pre-decided guest, Mr. Suhas Deshpande sir, can't join today's session due to some unavoidable situations. So we are extremely sorry for that, but we have arranged the alternative for that. Tomorrow, that is on Saturday, 2nd November 2025, 2 p.m. to 3:30 p.m. We were having Dr. Pudre sir's session. So today we'll continue with Dr. Pudre sir. Tomorrow's session will conduct today. So stay connected with us. Within a few moments, our session will start. We are very apologize for the inconvenience regarding the from the side of the speaker. So, Dr. Pudre sir, soon he will join us and he will deliver a session on digital transformation and innovation. Due to some unavoidable situation, Mr. Suhas Deshpande sir can't join the session. So, we'll continue with Dr. Pudre sir.
All right. So, madam, can you see my screen?
Yes, sir, it's visible.
Okay. Okay. So you can
Thank you
see
so
only
much,
one
sir.
screen or two screens or one screen, ma'am?
Only one screen is there, sir.
Only one screen. Okay.
Thank you so much, sir, for accepting our invitation at very short notice. And today, sir will speak with us on digital transformation and innovation. So, sir, if you are ready, then we can start the
Yeah,
session.
it's ready. I think. Yeah, I'm ready. So
Digital transformation and innovation.
yeah, I shared my slide. I think you can see on my screen or your screen. I think it's visible to everyone, I guess. Yeah, it's visible, right? It's one single screen. Hello?
Yes, sir. Visible.
Okay, so shall I continue?
Sure, sir. Sure.
Yeah, so no, actually, good evening, all the participants. My name is Dr. Ramesh Shankar. I'm a director at Era Foundation, and I'm actually Autodesk Senior Program Manager. I have been closely working with most of the industries where I've seen a kind of huge digital transformations. Now I'm actually currently working in innovation space to create a kind of ecosystem of driving multiple innovations in a different fields. So now in my today's talk, I'm going to also discuss about so that's my agenda, which is basically the context where I'm going to discuss what are the technical terms and the technical landscape, how it looks like in the digital. I would say it's like an industry digital transformation, because in industries what we do is actually reflecting and giving a lot of results to the end users and the customers across the globe. And there are some success stories I'm going to discuss one by one, because that's important for all of us to understand when someone is actually thinking about digital transformation, how it works, and what is the framework and the culture and some of the actions that you can take in your organization. Sorry, I mean, it was a plan for the next day, but I thought it's important for everyone for this industry digital innovation, I would say transformation and innovation. So again, I just repeat, my name is Dr. Ramesh Shankar. You can have the flow where which I will take you through the accelerating the growth in the age of AI and data, because all of us know that the age of AI is on us, and then data is becoming a kind of currency for all the companies, right? Now, and it is important for also understand the where the industries are actually moving, where is the trajectory moving, right? The idea here is the agenda. I want to do some kind of where we are going, basically, why you must transform now, and then what are the the 8 kind of technologies that really matter to all of us. Then 4 world-class case studies that I'm also going to discuss. Then there is kind of a framework, which is innovation framework plus the culture I have added there. And then finally we'll have the your personal 90-day plan, or maybe you can think about some of the ways you can apply in your organization also, right? That's the framework. Now the session objectives, if you really look at is crystal clear, which is basically understanding the digital transformation. There's no kind of buzzword. What are the 8 technologies that you cannot ignore? Then also we have a kind of 4 kind of proven playbooks that I'm playing for the success stories, including the Siemens, the Starbucks, John Deere, and the Domino's, because these are something prominent names I would like to discuss, and how to fix the culture, which is basically which is number 1 killer, right? In the whole process. This is basically a kind of 90-day field action plan with your organizations, if if they could start thinking about the digital transformation. But great that it starts with the wake up call. Now look at the burning platform right now. Look at this, around 88% of 1955 Fortune 500 companies are dead, right? How many of you know this? Because this is something, give us a call in terms of the company's rise and how these companies are actually evolving. What is the average lifespan of SAP, right? Say SAP 500 companies that has collapsed from 60 years to about 15 years today, and most of their digital leaders are actually grow the revenue twice as fast. So if you see, the 70% of transformation programs still fail, because that's where the companies can still fail, due to the processes within the companies, and industry where the always question is, it comes to their mind is whether you will disrupt yourself or wait to be disrupted, right? So that's why it is important for us to really go through this process, and these burning platforms also creating a kind of opportunity for us to just rethink you know about how we can, or in like the industries, how they can go build kind of fast 2x revenue with the new leaders which are thinking about the digital transformations. And that's the key kind of key in the upcoming session, right? Now, the definitions and the technology landscape that everybody need to understand, right? What is the definition of the technology landscape in the digital, the industry transformation? And it's not just buying a kind of using any specific software, and it is also not kind of an IT project. It is a kind of one-time thing. And that's basically it's builds this cross those out in from your mind, right? So that's an ITA project or only startups, right? So digital transformation is not getting into, because there are a lot of rumors and misunderstanding in terms of getting some terms and jargons, in industry to use these new softwares. The people are talking about, okay, I bought this new software and I'm doing the digital transformation of my company. It's not about this, right? So, but what is the digital transformation, right? I mean, it is obvious that we should think the paradigm shift, in the AI or in the artificial age now. The companies are, implementing the agentic workflows. There is a huge computation power, this available with the optimized algorithms, and then where, how the organizations are playing an important role for optimizing their processes, supply chain management, and it is not just by using new softwares, right, or in any specific. Yeah, right. So what it is, I hope you can hear me. Hello? Hello?
Yes, sir.
Yeah. So also it's a what is exactly all the digital transformation is. It's a complete new process. In my experience, experience, as well as how the industries are thinking. Industries are thinking about customer experience, and most of the faculties are coming from, the educational institute. So they should think about who is your customer. The customer could be your students and their parents, right? The customer experience is the first, on top of mind. Then second is the business and the operating models. And these operating models could be a kind of subscription. The business models could be kind of fixed cost models to all of us. And the third one is how we work, or how the technology is enabling us, right? So there are multiple technologies available in the market. It's enabled by the technology, and actually it's driven by strategy and people. So it's always, think about the technology. Which technology is helping us to do that, right? And write down the single most important slide today, because it's you are working on some project or a research, research project, in the colleges, and then working on a different research topic and papers as well. But what is the single most important point today? That the fundamental shift and rethinking is really important for all of us, right? And what is the single one unique thing which will help the organizations or any company to move forward in the next direction? And the elements of the each of these companies are technology. It is a strategy. It's also about the people, and and everybody is behind that, right? Many organizations have their SOPs, right? But some of the SOPs won't work, right? There are ways where these can be modified with the new processes, the new technology which came in the market, right? The new AIML algorithms which came into the market. So this is where the way the people should think of, which is a rethinking, which is also required, which is we call it as the industry digital transformation. I feel it's a most important to note down those points and think about, I have these challenges in my processes, and how do I solve that challenges? By which technology I can use it? What strategy I can use it to solve that particular problem? So I'll give you some very good successful kind of international examples for all of you to get and understand the digital transformation also. Now, these are the 8 technologies that is actually reshaping every industry. I'm not talking from 2025 to 2030, and that's a kind of brand new ideas you might get. First is the number one is generative and agentic AI. That's on the top of the mind, and every company is working on it. And you should think about these technologies, where I can implement and how I can implement. Where I can implement in research, how I can implement in my project, right? So the second technology is IoT plus edge computing, right? Now you might have heard about Internet of Things and the edge computing in these small the tiny phones. Now these AI algorithms are running very effectively and processing huge amount of data on site without internet connection. So the edge computing is also becoming important, right? And I don't see it as important, but it becomes the kind of default in technology landscape. Then the third one is the cloud native, right? The cloud native platforms. In the past, everybody's talking about software as a service. But right now, all the cloud native platforms are not talking about this language, because the subscription and other process in the software development have been completely gone. The new models have, they evolved, and that's basically the people are calling it as an API key, right? The cloud native platforms are becoming much more a kind of adaptive in understanding the different types of the data structure which is provided by the new algorithms, or sometimes any algorithm which runs on the AI agenting platform or a specific workflow. So this data structure is handled by MCP, right? So the MCP is also coming into in a big way to get the exchange of data between multiple models, or we can also multi-model, becomes really viable for us, right? And that is the the key thing in terms of the cloud native platforms now. Now the next the technology which is really reshaping the industry is 5G and 6G and on all the private networks, which we call it as, because the amount of the data it transfers through this the 5G and 6G the bandwidth is huge, right? And the industries are really focusing the 5G and 6G because it's actually enabling most of the smart factories now, and all our the current communication devices, if it really works in sync with the microprocessor, in sync with the industry control or the expected outcomes or desired flow. It could be the process where the people can put the constraint in terms of using the data live, right? All people wants to have a quick update and quick communications to the devices. For example, in the hospitals, in the robotic surgery and something, the 5Gen60 private network becomes important. All the remote places where now the new satellite technology, which is also coming in, as SpaceX has launched this internet at the remote places. So it is evolving, and it is going to that at the speed of light, because it's a exponential growth in 5Gen60, which is happening now. The blockchain and tokenization, and that's the huge topic, in my opinion, because in computer science and in all the banking services, the blockchain and tokenization is getting reshaped. The newer algorithms which are coming and continuously used by the finance industries, and it is creating a complete shift in that space. Now we have the extended reality. You might have heard of the technology which is Mark Zuckerberg said launched, which is now the next level, which is AR, VR, and MR, which is basically the mixed reality, which is is also kind of replacing our mobile phones, right? Everything is coming in your spec. It's coming on your wrist, right? With the gesture control, you're able to experience and change the videos, change the context, take up the calls, answer the calls, write the mails. You can do a number of things with these gestures and your ability to interact with this extended reality world. The hyper automation is, I feel, it's becoming a paramount for all the industries, as everybody wants to launch their newer products quickly. So therefore, hyper automation is the key, and other companies are really focusing heavily and putting a lot of investment in this space, as it is closely connected with the data centers. It is closely connected with the computing power. The last technology, we call it as the zero trust and the quantum safe security, right? Now, where is this, right? This is the phase where all of people are thinking about the quantum safe, which is the world where at least some of the all of like what the quantum computing is. It could be 1 or 0, or at the same time it could be 0 and 1 exist in the quantum state, but it as the quantum computing capacity is increasing day by day, and which becomes a threat for the security, right? Because all those banks in the finance where all the data is our data is saved digitally, so anybody can crack when this technology the quantum technology reaches at its a specific the peak level. So how it is going to be safe, how you can make it more safer there. Now, the quick real world impact by the sector I'm going to discuss, because the manufacturing, if you see, there's a quick scan the predictive maintenance and the digital twins, right? Now this is a bigger work. This is the major space where all the core industries are working, right? Now, when I'm talking about the predictive maintenance, actually, I think Siemens, and you might have seen some of the digital twins in practice by the multiple companies, because the digital twin means it's at the same time you have the digital model and the physical model, which will be perfectly synced, and you take a lot of insights when both the systems are in sync. Then another one is called as personalization, right? The real world impact, because AI personalization creating a huge complete new opportunities in this market. Because if you see the quick commerce, if you really look at the market, the consumer market, especially the people are expecting customization on the watch, customization on the T-shirt, picking up the new dresses, based on your the style and desire. It becomes a really quick, right? And that's where I feel there's AI personalization which comes into picture. The another one is basically the healthcare, which is also kind of becoming a huge market. I can see a lot of startups in India now, especially I've seen so many startups in the this sector is healthcare is growing. I mean, reaching around kind of 18 to 19 billion dollar a big business, where the remote monitoring and the AI diagnostics is also happening. Because in the remote areas, this becomes a kind of a boon for the people and the healthcare sector to really take care of some of the. Just hold on, I just is taking a shape, and then the banking and the it's banking, the embedded finance is coming into picture. Now, when I'm talking about the embedded, which means you have seen the cryptocurrency, you have seen the UPI ID, right? And the new ways for the banking are also evolving. And where I feel these are the real world stories, and where everybody can see that how that industry is got impacted with the new technology. Now, agriculture is a big space where the autonomous drones are coming in a very big way, doing a lot of activities, because in agriculture space we are not getting the enough manpower to to deal with all the agriculture in a space. But in agriculture space, autonomous drones are coming, and also the new tools which are or the kind of equipments which are now being used are also increasing the productivity, right? But the idea here is how different industries are using this, right? These in the agriculture field, because many industries are doing innovation in this space also. Because I was also part of one agriculture hackathon in Tumkur, because Tumkur is a big space where all the entrepreneurs and all these students might came, and then we had the kind of hackathon there, which is really nice. People went and into the different agriculture field and try to understand the problems, and not only innovated the autonomous equipments, but think beyond that, because we have a multiple the areas in the agriculture space to do a kind of automation, and build a newer equipments and the tools and the technology in this space, and that will help us to do a lot of precision in our farming process, right? Because if you do that, right, it gives the massive results, right? I am sure that because these are the real world impact by the sectors, and where the digital success stories are important, right? The other part is I also want to ask all of you is about these the sectors where I'm talking to you, because we'll take one by one case study, because we have a different success stories here. Now, when talking about this, the third part of my presentation about the success stories, of course, the first success story we'll go ahead with the Siemens. But what the Siemens has made a difference in their in their sector, what actually they did it, so we want to understand in a deeper way about what the industry digital transformation looks like, right? We are discussing all these trends. We are discussing the sectors where it get impacted, and even if you see the current trajectory of the largest investment in India is on semiconductor. It is happening in manufacturing space, right? It is also happening in healthcare, healthcare space. It's also happening in AIML, or it is also happening in the data centers, right? So design in manufacturing is the core part of most of the industries, and where there is new labs are being set up by the different companies across the globe. So these GCCs are coming in. I think you might have heard about it, but most of the GCCs are coming in the capitals where there is a kind of huge opportunity, because every GCC which is coming here are getting the employment or the talent pool from that city, right? Now let's relook at what is this digital transformation looks like, right? Now you have seen this Siemens, right? It's a beautiful case study. It's one of the you can say, I mean, we started. The Siemens has started almost they're founded in 1847, and it is one of the top company, right? And this company is in Europe. So how they transform themselves from selling the physical products into a digital industrial powerhouse, right? What is that these people have done it, right? Because this is in the top 5 companies, right? Top 10 software companies also there. But how they transform themselves from they were selling a small products, but they're transformed into a kind of industrial kind of powerhouse there. And as we have seen that they have used the 3 big ideas, in my opinion. But the first is they have used a complete 100% digital twins. Now, when I'm talking about the digital twins in their factory, in their production line, is something new approach or a new strategy that they have implemented. So what is the digital twin? It's an exact virtual replica of the process, what they are doing in the factory and what they are actually executing on the shop floor, right? So the engineers can really test a new production layout or a product change completely in the software itself before building the physical prototype, right? Of course, they can build a physical prototype and they can work along with that also, right? So that is again touching their physical factory, and the results were amazing. Around 50% of reduction in their time to market for a new product, right? So this is the first part of it also. Now the second, the important story about the predictive maintenance with the AI, right? And when I'm talking about the AI, where thousands of sensors are put on the machines and they send the data in the real time to their MindSphere platform, right? They have this MindSphere platform, and the Siemens has kind of industrial to IoT cloud, where the AI actually predicts when the part will fail, right? When it will fail, because if you don't know when it will fail, so we can't do a predictive maintenance, because it gives that prediction and the insights about when the part is going to fail, right? Now, in this, it really often we will get the kind of alert, to all of us to replace that particular part or do kind of service to that, instead of doing the scheduled maintenance. In all the companies, there is a scheduled maintenance. But before that, if someone is giving me the idea, if this part is going to fail, right? That gives me, additional benefit to maintain the a minimum cost and increasing the productivity. So this is where we can save a lot of money, and then breakdowns where most of the companies where they're talking about they can reduce it, right? But many companies, if they don't do this, what happens is there is a lot of breakdown. The production cost will increase, and that's where the this digital twins are making a huge impact in terms of saving the money and taking a quick action against the process, right? Now the outcome is for the company itself, right? I want to discuss about the outcome, right? When they implement, what is the outcome, right? They got around 1+ billion euros, as an annual saving, and that's where it created a difference, right? Because it will not happen just like implement and start working on the digital twin, but it reflects its power across all these platforms, and then their customer plans also, because they might be giving some of the 10-15 parts outsource, some of the vendors and other companies where they have also got it corrected, which in the one. So this is kind of one example. They have this example is there is a product called as One Rail, and they predict the rail switch failures with 99% accuracy, and the trains almost never stop because of these broken switches, right? They have this another factory, Hamburg, where they have set the benchmark in electronic factory. This is based out of Germany, and they have done around 70% of production process fully automated. Everywhere the machines talks to the products talk to the machines, and the humans mostly supervise and solve the rest of the issues. That becomes easy for them. Now, if you really look at the defect rate is rate is 11.5 parts per million, almost. If you see the Six Sigma perfection, it is around that, and they produce around 7 million products per year with the same number of people they had 25 years ago, right? So if you really look at Siemens, no longer just sells you a kind of gas turbine. They sell you the power as a service. You pay for megawatts produced, and they guarantee 99% of uptime using digital twins with AI, right? So the key, what is the key takeaway? Key lesson from the Siemens is digital transformation is most powerful when you apply it to your own operations first. So which means eat your own food first, and once the Siemens perfected it internally, so they turned it into a kind of a 6+ billion euros digital services businesses that they now sell it to other manufacturers. So that's why Siemens is a kind of example of Industry 4.0 and who done it right? So that's the first case study that I want to highlight. The next case study, it's interesting. I think you have in the cities you might have seen the Starbucks, right? Starbucks normally they go from heavy industry, something everyone in this room to understand the coffee, right? 10 years ago, Starbucks was a kind of completely a traditional retail chain, right? And the people used to stand in queues. They have these paper loyalty cards, and the most sales happen over the counter, right? And that counter is like you go to any shops, like we in all our places in Bangalore, and especially in where I live, right? We have places where this we call it as a cafe coffee day, which is CCD we call it. So today this is the same way. It's like because I'm just looking at their global network. So it's just one of the most sophisticated and what is the digital transformation? What are they? Now I want to discuss with you. So what they built one of the most sophisticated digital consumer platform on the planet. So there, even executives say we are the tech company that happens to sell coffee. Okay. Now the people will say, but this is one of the big technology platform that these people have built. So how they built is important, right? So they call it as a digital flywheel, which means the number one is they use the mobile order and pay, which is one of the best feature, I would say. You can open the app, order your drink, and walk into the store, or skip the entire line and pick it up, right? So what happened the moment they've implemented this feature? So they have seen a huge surge in the process, which is more than 30% of all Starbucks transactions happen worldwide, and now it's happened through the mobile order and pay, because you don't have to wait in the queue. You don't have to talk to the people, just go on the mobile and get it, because it's a coffee, but the people wants to save a lot of time. We have seen a lot of change in urban stores. It's more than 50%, because everybody is busy and they wanted to go for different business meetings. So that's a single principle which they have reduced their waiting time, increased the throughput time, and also made customers come more often, because that's the whole thing. Second is the Starbucks reward points. They have introduced this a new feature. Today they have 31 million active members in US. In India, you can see India is still it's growing, but I'm just talking at worldwide level. They have the bigger than most of the bank's customer base, right? You will say that how many members are there, because they love the coffee, so they purchase every offer they accept, every location visit is tracked, and that gives them more kind of first party customer data, almost any retailer on this earth. Then the third point I want to also focus in Conduct, they have this Deep Brew, their secret Gen AI weapon, and they built an internal platform called as Deep Brew. And yes, it's a coffee, pun intended, but it uses the generative AI and machine learning to personalize every single offer in the real time. You imagine every single offer, in the real time, how the platform can manage this, right? What type of digital transformation that they have done it. And it should be excellent, I would say, because if you usually buy a kind of cappuccino or something, the app will give you a kind of personalized offer on Monday night for exactly what the drink and redemption rates that they can use it, because they predict that what you want to, what you will go ahead. I mean, it's basically you with the AI and all these predictive capabilities of Gen AI, it is helping us. Then the fourth one is called as flywheel effect. More apps usage, which in turn you're getting a lot of data, better personalization happens, more visits, more spending, more data, even better personalization, I would say. It keeps us spinning faster, and most of the customers who come again and again, 3 times more than what the earlier the people who used to come at the counter and the desk where the customer visits. So that is increased. So what is the something which we have to think about is the financial proof. Some store sales growth has consistently beaten industries for the years, and during the pandemic also, stores were actually all the mobile order stores become profitable. In India also, we have seen a lot of surge in the e-commerce. That is also helped. But this is one of the kind of prominent examples worldwide, because the revenue they have collected is huge as compared with other companies. They started with the customer pain point, waiting line, and not with the technology. So the technology is simple app, AI, cloud in same second, but the customer problem first come, and then they have solved this. So today, Starbucks the market cap is higher than the Coca-Cola, right? Or Pepsi or McDonald's. So it's combined together, and they are driven by all the digital engine. So whatever you are, thinking about, making turbines and cappuccino, the simple principle here is solve a real customer pain point at the scale, wrap the world-class technology around it, and the money follows you, right? So that's the simple principle this case study, is talk about in this process. Now the third case study is you will see this picture, right? John Derrick, right? Now, what is this? This is a kind of 187-year-old company, which is really famous for green tractors, right? very famous, and it's now one of the world's most valuable agriculture plus AI company, right? Now, how? So what John Deere and market value has more than doubled in since 2019, and it is not because they suddenly sell twice as many tractors, but something they have done differently, right? Of course, they have done a digital transformation, but how they've done it, right? So you need to understand from the digital transformation perspective. So they have they completely focused on some big moves in their company. First, they stopped selling iron and started selling uh, uh, the outcomes. Now, this is interesting. Yeah, this is really just 1 second, just 1 second. Sorry. I just took home water. Yeah. So here they completely focused on the selling the outcomes, right? In short, outcome as a service. And the farmers, they don't want to own a huge cost tractor, right? I don't want to get into the price, but they want higher yield and the lower cost per acre, right? So how they have done it, right? So they want higher yield and the lower cost. Of course, everybody wants to. So this company, John Deere, what they have now offers tractor as a service, right? They're going and tractor as a service. What they do is they do a kind of precision planting subscription. This is, I think, the service what they have started is called as precision planting subscription, and even the farmers pay for this service for this carbon. But the company started, and then in the meantime also they started collecting the data, right? So the tractor is just kind of hardware for them that delivers the intelligence to them. But see that what they've done. The second thing what they've done is they focused on the see and spray select. So what the AI does is the AI that sees the weeds and only kills weeds, right? They've used the AI in that, right? Traditional sprayers blanket the entire field with the herbicide, but most of it actually hits bare soil and runs off into rivers. But what they've done is they have done it differently. So they have mounted cameras. They have used the deep learning AI on the sprayer itself. That is called a sprayer boom. And, as the machine moves at 20 km per hour, it identifies every single plant in real time. And this is in India also we can do it, to be honest. It recognizes all the crops versus weeds, and only the sprays goes on the weeds, right? And you can't imagine 70% less herbicide used on an average. So you reduce your herbicide which is used there, and it goes up to 90%. Look at the saving. Farmers are very happy because it's saving a lot of things, and it increase the farmers save up to huge amount per hectare. And the environmental impact is also really massive because you're not harming the the nature. The John Deere actually Operation Center, Farmers Digital Brain, every piece of equipment, they have the tractors, planters, combines, and everything is connected. It's just like IoT. You can see it's IoT or a kind of digital twin. It is connected on all the data, which really flows into a one cloud platform. It really do kind of mapping of the entire field. It do kind of soil mapping, weather conditions. They also process the satellite images, which is they can visualize, analyze these data, and then the machine can perform. So the idea is the digital transformation. The farmer can really use it, and then even the farmer can sit in office and plans the entire season, exactly how much seed they need, how much fertilizer they need, and how much water they need. So everything is like kind of, you can see the automation, and a lot of insights are coming through this case study. So the tractor then executes all autonomously. Outcomes are farmers are using full platform, 15 to 20% higher yields, and 10 to 30% of the lower, I would say, input cost. So one real quote from this farmer said, from US farmer, I went from guessing to knowing exactly what my field needs, and this company equipment now makes more decisions than I do, and it really makes better ones. That's interesting. This is a key takeaway, from this case study. Even the oldest and dirtiest and most traditional industries farming, but due to this digital plus AI can create completely new business models, a massive sustainability, wins at the same time. So they turn completely a kind of commodity product, a tractor, into high margin, recurring revenue, data and outcome platforms. And I guess what farmers who adopt the full John Deere, digital ecosystem, always, use their brand. So this is a nice, I would say it is a lot of profit and benefits to everyone. So the idea here is, right, we have seen some of the examples of agriculture, and they use the technology, right? Even if it is kind of expensive, but it is actually solving most of your problems, right? So now we are transitioning to see how the another food industry, right? We can say the same logic is turned for the pizza chain. It's all of the Domino, but it's one of the, I would say it's the best example of how these people have done it, right? The transition to their into business, because almost the company is about to fall, and then due to this digital transformation, so they have picked it up, right? Of course, there is a huge data processing which happens, the platform building happens, but yes, we need those technical thoughts and details and algorithms to quickly take the decisions and make any a business into a kind of scalable as well as a kind of profitable business also, right? Let me go to any questions you people have.
No, I just posted a couple of comments with Ramesh. That's an interesting talk. So I think they are in my chat box, but we can read them later. I think you spoke very nicely about topics and nomenclature that are used nowadays, but you're actually showing good examples, very good examples. So I know that in Germany, I'm sure in India, other countries, they use these techniques to also identify the insects which are undesirable under the soil, in farming at least, and to use those undesirable insects and worms that are harmful to feed the other wing creatures like birds, maybe their chickens, if they are not harmful to them. So I think drones also play an important role. So all these technologies that you're talking about is being used. I know in drones too in India and other countries. So I think, please go ahead. I just want to, you can read these comments later. Yeah, thank you.
Yeah, thank you so much for your comments. Thank you. So the next story, transition of the case today is now would like to see the another company above Domino's, right? Yeah. So this is, I think this is exciting story. I think, especially the professor who are into and the cities. I think everybody knows the kind of Domino's, and we enjoy the pizza. But this is I guess in 2008, Domino's was actually a serious trouble. Many of you are not aware of, but this is the company who was actually having a really big issues in their in kind of business, because the stock's price had crashed about their around $3, and customers hated the test, what they literally said in their the focus groups. So they were actually losing the kind of Pizza Hut and Papa John's. And then I think the Patrick becomes the CEO in 2010 and did something almost no one expected. And this is also in public, and I hope this is the best case today I would say in the kind of Domino's pizza. Even a lot of Indian startups who are coming in, and I feel there's kind of little struggling on that. So what is this new change? I feel is what is something expected, right? He admitted literally publicly their pizza is tested terribly. It ran the famous "We Are Sorry," right? The campaign "We Are Sorry," and at the same time they made a crazy bet like we will become the world's greatest e-commerce company that happens to sell pizza. So it really goes in a way. And here is how they pulled off one of the greatest turnarounds in the retail history. Pizza is, I would say, is the original clickable item. They built the Domino's. It's called as Anywhere. You can literally order pizza from anywhere. So the idea is they tweeted that pizza emoji to Domino's pizza arrives. Say that Alexa, they implemented that. Alexa, ordered my easy order, right? The text a pizza emoji to their number and order from your, from the screen itself, right? You might have some kind of Samsung smart fridge or Apple Watch or even your own smart TV. You can quickly go 20 different ways and then try to keep that adding more. So the second thing is this is the world's friendliest voice ordering AI. So they've implemented the first time, I guess, and this AI or the app can can talk naturally to you. It's like a human being. It's a one AI agent, right? So we can talk to you like, hey Dom, right? The usual, but add extra kind of sense of their sense of connecting with the human being, and make it really quick, for someone can understand quickly, and it confirms that place and the order in seconds, and the accuracy is now more than 95%. And that's a big shift, in the kind of digital transformation. And we feel that this Domino's tracker, they've used it with a lot of transparency, turn into kind of addiction, which is kind of real-time, tracker shows exactly where your pizza is. You can prepare it, oven, and then quality check is tracked completely. So they build that kind of transparency in their processes. So what the digital, one of the, I feel in the overall process, if you keep the customer, aware about the processes, like where they exactly your ordered product is, right? And then it gives this kind of confidence for us to really see, you know, its delivery on time, right? And of course, this quality check, right? They have put into a different. It's now in preparation phase. It's in oven. There's a quality check, and then again out for delivery, right? And then it also shows you the time, right? I mean, it gives that kind of quick. I would say the quick status of your order, on the app. So it's basically gives a lot of satisfaction to the customer. So now if you really look at it holistically, the customer is exactly at the center, right? All the processes and the technologies around, around it, and technologies used in the processes to do automation and gives kind of experience, the best experience to the customer, right? Now, the another one is, as I just mentioned, they have used the digital flywheel. It's more like more digital orders, more data, better predictions, faster delivery, and most of the people are very happy when you deliver, on time, and the test is the maintain in the pizza, right? Today, more than 80% of their sales are digital, right? That's the magic of the digital transformation. It is a kind of heavily implemented. And this is the highest of, as compared with worldwide, if you really look at that's I would say the maximum sale. The newer startups and new technology, the new, pizza, newer brands are coming into the market, but still there's a kind of Domino's is kind of the market leader in this way. So if you really look at the kind of stores, number of stores which are there in the city, they are also growing, and their quarterly business is also growing as compared to the earlier business. But I would say, in the food delivery itself, they have beat most of the players in the market. And then they're performing really good in especially US and other countries. So here is the if you really see what the former digital officer said, I want to quote this line. We sell about the same number of pizzas we sold in 2008, but we just sell them in a completely different way, and we make a lot more money doing it. So the key lesson from the Domino's is it applies to not only this for the company, but this is actually gives a very good perspective for us that digital transformation is not about your product. It's about removing every beat of friction between the customer wanting something and getting it, right? And that's it too. Take away from all these success stories. So they didn't invent a better pizza, right? But the pizza is same, but only the process, the digital transformation, they used it and connected, to the customer, and removing those kind of friction points in the processes. So it becomes a kind of a very good experience, for the users in the overall process, right? Now the frameworks and the culture, right? This is important because my topic was on the kind of industry digital transformation and innovation, but I'm also looking at how the innovation and the framework that really works for us, right? Now there are multiple things in the market, right? If you think that this is actually delivers the results, and I'm sure that these frameworks are actually delivers the better results. Now, when I'm talking about these results, because it's all outcome as a service now, everybody's thinking about how do I get the maximum benefit, right? Now, the first step, in this framework is the design thinking, right? The design thinking, of course, starts with the customer, the empathy. It's trying to understand what is the customer pain points, more towards in connecting with him and understanding more in detail, because that's where the first step, which is very, very important. Of course, now in the design and innovation thinking, we do a kind of a simple, straightforward process about empathy. Then we call it as problem statement, ideate, prototype and test. Right? That's anyway. This process is being applied. But moving forward in this framework, I feel the digital or design thinking comes into really works really well. Then there is another called as the lean startup, right? When I'm talking about the lean startup, which means basically starts, from how to we build and then measure and then learn, right? You start a particular process, like for example, from the design thinking process, you understood a certain parameters about the customer needs and its requirements, and then in lean startup, we are completely kind of iterating. We build it, measure it, and learn it. Right? It's a small type of innovation. You can say it's a small subset of innovation. We are iterating as a lean startup, building and measuring and learning again and again. That's where we focus as a kind of framework. Third is jobs to be done, right? Where we should focus on the customer is really hiring your product to do it, right? Jobs to be done, right? Now, if even if you set your in the digital transformation framework or innovation framework, even new process, even if you want to build it and you have measured it, and if you feel that it is working, right? Now you have to really look at the feasibility part of it. Jobs to be done, right? What is expected to done it? Like what is its functional parameters? Where the transformation has to happen. Whether we have designed, we have thought of some requirement, and whether it is really fulfilling, at its place. That's something which is jobs to be done is important, right? And it focuses on the customers really hiring your, really using your product, right? Then the last one is the fourth one, which is basically OKRs. Okay. Now, when I'm saying of the OKRs, right, what is the OKRs plus dual transformation, which actually protects the core business, right? Now, if you see any business in the market, right, it's always a kind of measure, all businesses has its OKRs, right? Which is basically key performance index, right? Where whether it matches with that, right? You have set some of your targets, right? From your core business to you might increase your revenue by 10 to 15%, provided you sell this many number of the items in the market, right? So that might be your goal, but you have to think about the your OKRs also, right? You cannot lose your the core business values where the business is actually earning or giving some output. But in the whole process is the protect core and build the future, which means we don't want to go away from our traditional business, right? The business remains same, but on top of that, how do we build a kind of our framework or a system which will give a more productivity? On the top of that, right? The baseline will remain same, but how do we transform that effectively, keeping the core, the business core remains as it is, but you will build a kind of futuristic features. You can build of features which will reduce the friction between the customer and the company, or between the different cycles, the customer experience cycle. If you really look at and focus on that, and in their journey, if you reduce that friction in between with these steps, it really makes that difference. That's where the innovations can really play important role. Because we know that digital transformation is important, but how do we apply, right? What is the framework that you need to do it, right? So I feel is this is the I feel it's a kind of good framework which can take care of the keeping your core business, while you can also try the building the future features on top of that, and it gives the yield, it gives the double benefit for you. So that's the you should have the approach with it. The another is this is the from the McKinsey study, which has studied a kind of thousands of transformation, and which has the number one reason reason they fail is due to the culture, right? It fails the culture, not money, not technology, but it is due to the culture. If the people are afraid to try the new things and fail, then nothing else matters. So this is I think remember Peter Duckworth, right? Drucker, and he what he says is the culture eats the strategy for the breakfast, and it eats technology for lunch. So that's where there is always kind of resistance to change, and it goes deep into their thinking mind, and coming out from that could be a kind of challenge. Of course, this challenge is every business leader has, and that challenge can be can be solved, or how to deal with that is also we will talk about, but you first understand this is the culture, right? It's the it's the complete strategy, right? We have brilliant ideas, we have a lot of new things that what I want to build in my company within the processes, so that company becomes profitable. But what happens is, what is the number one kind of killer, right? And which is transformation. In this, we have to identify those things and how we should win, to build the better culture for us, right? I mean, that is the main thing. So this is a study, a kind of abstract from McKinsey, and the people have gone because people understood, the business leaders understand, okay, I want to do it, this culture transformation, but how do I do it, right? So let's talk about this because it's important, how do we win it, right? Now, this is the first things, how winners can build a culture is that leaders go first and they use the new tools, right? 5 things best companies can do is leaders use the new tools first, and no exceptions, right? So no exceptions. Then what we do is we celebrate the intelligent failures publicly, right? It's a publicity. Then run internal hackathons or innovation days, right? Hackathons days. Then you can give 15 to 20% of time for experiments as well, right? If you don't give the time, what will happen? Because if you don't give the time for them to innovate, it is not innovation. It's just a kind of simple process, right? So what the best companies will do, how the winners can build this culture is, and hire for curiosity, not just for the skill set. If you just go ahead with and just think about I wanted this experience, but if that person is not curious to these, and culture will sometimes the culture will also stop being the blocker. So it becomes the accelerator in this, right? So hire for curiosity. That's we say, and these are the some kind of how the winners can build the winning culture in the whole process, right? So any questions and I think how the winners can build a culture, because you might have some kind of, we'll take some small break up and trying to understand how do we kind of take some action and close it here. I think the most of the the college heads and the principals, the leaders might have also joined us, right? So they might have some their thoughts. They can also talk about it, right? And yeah. Yeah, any action, right? So, I mean, do you have this kind of it? Because I go to the first slide here, the previous slide, Oops. Yeah. So here you feel that these are the your own, I mean, the pain points for the transformation. What do you think, right? Anybody, who has, from his organization perspective, we can also talk about, right? Without taking any name, because we don't want to take any organization name here, but trying to be safe and be a part of be a part of kind of how do we innovate, right? How do we take some proactive steps to ensure that there's kind of digital transformation there, right? Because people will try to try new things and sometimes they will fail, right? Yeah. All right. So what I mean, I just focusing on these kind of best companies. What are the best companies we do? I just want to repeat. They first use the new tools and new technology, right? That's what I emphasized. Some of the new applied AI agentic tools in the platforms. If people are using it, right? For various problems, right? It's may not be your organization, but it is used for your research, for a business processes. It could be used for any manufacturing process, right? That it will give a lot of insights when you apply it, right? New tools and new technology, new platforms, because these are built based on the current problems in the industry, right? They have focused on, these are the gaps, these are the problems, and that's where all the companies are standing, right? Those based on your problems, they build the solutions, right? So why don't you try that, right? Use the new tools, try that, right? So that's the best way to build a kind of culture of innovation there, right? And then, of course, you should celebrate if you have some failure. And in companies and organizations, we run these kind of internal hackathons, right? These hackathons, makes all the employees, always curious, right? Always, work on their work on some new challenges, work on some of the new workflows, what they feel is the right, and implement it, right? So innovate, right? they start building it, right? So the building is the first process, and trying is the first step in the innovation. So we should spend some time, right? Each one of us to get used or build this kind of culture within the companies also, right? This is the action and close. So we have to think about a 90-day kind of action plan, which normally we suggest, right, to the action and the close. We should not kind of think, pick the first, pick any customer and how you start doing the design thinking process here. It is basically the first process to solve their problems, right? And then maybe 5 to 8 weeks, you start thinking about launch of one pilot AI or automation data. You can scale it from 9-week onwards. You can measure the results, plan, scale, and train the team. So so you can take out this kind of template also, and you can plan in phases, right? We really believe in terms of doing the kind of field visit, putting all this, pick one or big idea or a customer problem, put it in the framework, access where, give them, right, these are the possible ideation phase and the solutions it has, and then apply them. Okay, there are some technology which is available, try to use that, launch the first run where it can create a kind of impact. Some of the places it may not give the kind of impact in the first go. Everyone will get to struggle, how to do that. It might fail, it may not work, right? But we have to do a kind of a focus, right? The access from the next scale. That could be a kind of, I would say, the action plan, a 90-day action plan, because most of the people just talk about technology and then they don't talk about what action we have to take, right? But if you take this kind of printed template and apply it, right, even for your research problem, this is the best way to think about it. Or some students have a kind of wonderful idea, right? If you guide them in terms of making this kind of handy, or a kind of making this their 90-day action plan, that could also helps, right? It's because in this place we are focusing on the customer problem, accessing, and then we can run kind of one high impact pilot, right? I'm talking about pilot because it's the first time you are doing, right? You're doing some automation, you're using some the large language models, you're using some hyper automation, different AI studios. So the data is being used and consumed and processed to these algorithms to get a kind of outcome and the results, right? And this has to be kind of measured, right? If you don't measure the outcome, right, we cannot scale it, right? If it is if we think that if we measure ROI on that, then only you can scale it, and you can also train your team. So once it is fixed, so this is this is kind of one template, and in this also template, if I want to just deep dive into the different the action plan, is you can think of is like identify and select one major customer pain point, right? Not only two, and who will take that ownership and metrics. So we have to be problem has to be defined properly. then in week 5 to 10, as I just mentioned, I'm just going to the deeper 90-day action plan template. So here, design and launch a kind of pilot project to address the problem. And when I'm talking of launch, you have to get the technology embedded or technologies used to address the problem, right? Because there are many technologies, is available in the market, but at least you have to write, in person, with the proper goals, and the last is you have to analyze all the results, right, and plan for the broader implementation plan. That's kind of a framework and the actions, template for to create your personal implementation plan, or can say the contract. That's how it will work, and it's important for all of us to have some takeaways through this. Now I would say these 4 things to remember. I would say one is the start with the customer problem, never with the technology. If you start with the technology, then you'll get stuck, right? And many of the failed companies, they will start with the technology first. It is not starting with the technology. It is starting with the customer problem and never with the technology, right? Then second is about the culture and the strategy, right? How it should have to go if we are implementing a kind of specific strategy with the technology implementation, that has to be accepted by everyone. If there is a kind of friction, you should take a kind of proper steps to change the mindset of the people within the organization. Then begin with the small and learn fast. That's important. Begin small, learn fast, and scale fast, right? So that is your one of the the takeaways. Your field 90-day plan is your ticket out of there, and thank you. You have a drop, I think, your MCQ sheet also. I'm not sure whether we can have this MCQ, but MCQ's plan, we have shared this MCQ as well to check the outcome of this kind of the talk. Yeah. Thank you.
Thank you so much, sir. If participants are having any questions, doubts, and queries, they can ask to question, sir.
Yeah, I stopped my screen. I guess you can see. Yeah.
I think, sir, participants are not having any question. So we'll sum up the session. Thank you so much, sir, for such an enlightening and informative session on digital transformation and innovation. Sir has clearly defined digital transformation. Also, the case studies Sir has presented were really informative. The 90 days action plan is just an incredible idea. Hope that today's session will be really useful for the participants to understand how to build an innovative culture. And within a very short notice, sir has agreed to conduct the session. So, on behalf of Sant Gajanan Maharaj College of Engineering, Mahagaon, we are really grateful, sir, for your immediate response and conducting the session. Also, I'm very thankful to all the participants for attending the session and listen patiently. So once again, I thank everyone. Before we end up the session, I request all the participants to kindly turn on their webcams so we can take some snapshots. Participants are requested to turn on their webcams.
Yeah, you can see my image.
So once again, thank you so much, sir, Dr. Pudare Arias, sir, and thank you all the participants, and good night, everyone.
Thank you. Thank you. Thank you, madam. Good night, madam. Thank you.
So tomorrow you have the sessions or no session tomorrow?
Tomorrow
there
there
is
will be
session, sir.
session. Tomorrow there
Closing.
will be session.
Yes.
Also the valedictory session.
From 2 p.m. there are 3 sessions, sir.
What time?
Tomorrow there are 3 sessions.
Oh, okay.
Okay,
It's starting at 2 p.m.
Yes, sir.
Okay. It's a little bit early for us, but I'll see.
Okay, sir.
Thank you. Very good. The other quick question I had was so these presentations, it's a big task. So they will be available through a link, or how do you plan on sharing those presentations?
Sir, we actually upload those on ATAL portal, sir.
Okay,
And from
NPTEL.
that, yes, sir. And every participant should log in from their credentials and navigate to there is a separate login there for each participant. And there is an important document section, and each participant will get all the study material on this presentation and from there.
So you're going to send us information about that, correct? By email or something when once it's done?
Yes, sir.
So it might take a few
Definitely.
weeks, correct?
Okay, sir. Okay. No problem. I definitely share with you.
Thank you. It's very good.
Okay, sir. Thank you.
Bye.
Cool.